Kungs, dāmas un kungi, sveicu jūs visus jau 6. ACDC Tech Forumā. Laipni lūdzam! Mans vārds ir Artis Ozoliņš. Es priecājos būt jau atkal šodien kopā ar jums. Un, kā redzat, tad pasaulīgie notikumi ietekmē mūs visus, un mums tiem ir jābūt gataviem. Man ir bijusi tā unikālā iespēja un tā pieredze dzīvot līdz ACDC Tech Forumam, un tas tēmu klāsts man šeit ļoti labi iezīmē katru gadu un tos notikumus, kuros mēs dzīvojam. 21. gads, pirmā reize, toreiz runājam par klimata neutralitāti, par izklaidoto ģenerāciju, tad, diemžēl, sakoja agresora valsts Krievijas iebrukums Ukrainā, un tas ļoti izmainīja arī tēmas, par kurām mēs runājām toreizējā forumā. Esam runājuši par aktīvo klientu, par gatavību, par drošu elektroapgādi nedrošos laikos, pērn kopā ar Ukrainas kolēģiem. Un katrs gads ir atnesis savu mācību un savu, varbūt pat sūro mācību stundu, kas mums ir jāņem vērā. Un 25. gads tādā ziņā, ja atskatāmies, izceļās ar vairākiem lieliem notikumiem, varbūt arī paskatoties plašāk, tad pērnā gada janvārs vētrā Aizraujošās spēcīgākā Britu salās, kas nesa arī lielas destabilizācijas sistēmā. Iberijas pussalas gadījums, par kuru mēs šodien parunāsim, Spānija, Portugāla, daļa Francijas piedzīvo tādu lielāko kaskādes energo krīzi, iespējams, mūsdienu Eiropas vēsturē. Un, protams, agresora valsts Krievija izaicina kritisko infrastruktūru ne tikai Ukrainā, bet arī plašākā liecina pat nesenie kiberuzbrukumi arī kādam ūdens apgādes centram Polijā. Tā kā katrs gads nāk ar savu mācību, bet kas ir šī gada mācība? Kas ir tas, kas mums ir jāizdara? Kas varbūt ir kāds mājasdarbs, ko mēs vēl neesam izdarījuši, lai mēs būtu gatavi? Jo šodienas lielais atslēgvārds ir noturība, un tas cauraudīs gan prezentācijas, gan arī diskusiju, kas sekos pirmās daļas noslēgumā. Un pēc tam visi klātienes viesi būs laipni aicināti pievienoties jau blakus zālē, kur mēs prezentēsim projektu MUPSIS, kas ir zinātniski sasniegumi, kas pēta elektrostabu puvi, lai iespējams laicīgi to pamanītu un novērstu kādus bojājumus. Un tai skaitā arī vairāk tiešām forši un praktiski piemēri no mūsu Sadales tīkla kolēģiem, kas ir ļoti, ļoti inovatīvi. Bet tas jau vēlāk pasākuma otrajā daļā. Par visu pēc kārtas. Pasākumu atklāt un vārdu dodu augsti godājumam klimata un enerģētikas ministram Kasparam Melnim. Sagaidām ar aplausiem. Sveicieni ACDC Tech.
Sveicināti. Tu uzdod kolosālu jautājumu par to, vai mēs esam gatavi. Un es tev teiktu, 30 gadu atpakaļ, jā, es zināju, kur ir svecīte, un es zināju, kur ir sērkociņa mājās. Un, kad pazūd elektrība, es ļoti labi zināju, ko darīt. Mūsdienās šodien jāsaka paldies tieši jums kā nozarei par to, cik jūs esat pieradinājuši mūsu patērētājs pie tā, ka elektrība ir stabila, elektrība ir droša, viņa vienmēr ir. Un tajā momentā, kad pazūd elektrība, es vairāk arī pats nezinu, kur tev stāv kur man mājās stāv sērkociņa vai vispār ir svecīta, ko tādā momentā lietot. Un tas pateicoties tāpēc, ka enerģētika ir viena no tām stabilajām nozarēm, uz kurām mēs paļaujamies, kurā ir milzīgi darbs izdarīts, ar ko mēs varam tiešām kā arī kā valsts lepoties, un mums vajag lepoties par sistēmas stabilitāti. Mēs kolosāli atslēdzāmies no brela, un pat ja šodien tu pajautās lielākajai daļai cilvēku, neviens vairāk neatcerēsies, nezinās, kas tas par, ko kāds vispār no kaut kā mēs atslēdzāmies, kaut kur pieslēdzāmies, bet nozara tā, kas to zina, cik ir izdarīts milzīgs darbs, cik ir ieguldīts, cik bijuši izaicinājumi un cik tas lieliski izdevās. Jo labākais bija tas, ka tiešām notika, tā kā mans igauņu kolēģis teica, kā būs atslēgšanās. No rīta piecēlos, iedzēru kafiju un esmu atslēdzies. Un tā arī notika. Un tas pateicoties jums kā nozarei. Protams, mums turpinām attīstīties, lai būtu drošāk un stabilitāte. Jāsaka paldies visiem iestādēm, kur papildus finansējumu meklējam ar Eiropā, un mēs to spējam sasniegt dzirdīgas ausis, lai būtu vēl stabilāka sistēma. Ir kolosāls darbs, kas tiek darīts kopā ar kolēģiem reģionā, kur mēs ejam jau tādām praktiskām lietām, skatāmies gan par to, kāda mēs esam vieni paši vai kāda mēs esam kopā, un tādas mazās niecas, par ko tagad strādājam kaut vai, ja ir rodās tas blackouts uz pāris sekundēm, lai mēs varam ātrāk tikt atpakaļ pie gaismas. Un tas ir ļoti izaicinoši. Un tas viss tiek darīts, un tajā saka tiešām milzīgs paldies jums par to. Un tie ir tie soļi pa soļiem, ko mēs darām. Skaidrs, ka izaicinājumu ir daudz. Tā ir arī viena no nozarēm, kur ir visapdraudētākā, bet mēs tiekam ar to galā. Un te ir jāsaka tiešām liels paldies nozarei, katram no jums par to, ko jūs darat. Un es gribētu teikt paldies par to, ka pieradinājāt mūs kā patērētājus, ka elektrība ir, viņa ir stabila un droša. Un man liekas, mēs visi zinām, ka viņa būs arī rīt tikpat droša un stabila. Par to gribētu teikt paldies visai nozarei, un mums vajag tieši tāpat turpināties. Bet mums vajag noteikti atcerēties tos un būt lepni par to, ko mēs spējam izdarīt un varam izdarīt. Par to, līdz ar to paldies vēlreiz jums visiem par to iesaisti, un kopā mēs varam sasniegt daudz, un mums lieliski sanāk. Paldies jums!
Paldies ministram Melnim! Paldies jums! Kā redzat, mums arī sānos strādā mākslīgais intelekts. Šodien mums ir arī viesi no ārzemēm, tāpēc ļaujiet nedaudz pārslēgties uz angļu valodu. Switching quickly to English, I would like to welcome all our guests who have traveled from afar here to ACDC Tech. On these screens on the side, you see AI translations from Latvian into English, so you feel more welcomed here at ACDC Tech. I hope that you enjoy this day, and a few of you I will see on this stage here as well. Sāksim ar pirmo stāstu. Pirmais stāsts nāk no mūsu goda viesa, kura pieredze ir tāda, kas vairumam no mums nekad noteikti nav bijusi. Virsnieks, izlūkdienesta profesionāls, bijušais Satversmes aizsardzības biroja vadītājs un šodien drošības eksperts, kurš nebaidās teikt to, ko mums ir jādzird. Pavisam nesen kādā Latvijas televīzijas intervijā, varbūt izmantošu citiem vārdiem, bet teicāt, ka Latvija ir ievainojama, tīpaši enerģētikas virzienā. Tāpēc šodien uzklausīsim šo kungu par to ģeopolitikas realitāti, kurā mēs dzīvojam, un tajā realitātē, kurai enerģētikas sistēmai ir jāspēj funkcionēt, neatkarīgi no tā, kas notiek apkārt. Dāmas un kungi, ar jūsu aplausiem sagaidām ģeopolitikas pētījuma centra vecāko pētnieku Jāni Kažociņu. Laipni lūdzam!
Paldies, ministrs kungs, dāmas un kungi. Jūs visi, es zinu, labi protiet angļu valodu, un tie, kas skatās no attāluma, lielākā daļa neprot latviski. Tāpēc es šoreiz atļaušos savu uzrunu veikt angļu valodā, tā lai mūsu datoru palīgi nepielaist nekādas kļūdas. So I will continue in English. First of all, like in the old Chinese curse, we live in interesting times. During the last 5 years, we have seen two of the most powerful military powers in the world, Russia and the United States, break the first principle of warfare, which is taught in almost all staff colleges worldwide, that is selection and maintenance of the aim. Neither Russia, Putin, nor Trump, USA, have been able clearly to define what their aim is in Ukraine or in Iran, and we find that those aims are changing all the time. The reality is that we are living in new ways of warfare. And this change which is coming about is comparable to that which took place between the First and Second World Wars, when military capabilities changed from cavalry and horse transport to heavy metal and mechanical transport, or indeed the change which came about through the introduction of aircraft. Since 1911, even in the First World War, air power became extremely important, particularly for reconnaissance. What we are seeing at the moment in Ukraine is a change which is comparable in importance, but is happening at an incredibly fast rate. And we are seeing the development of something which will become probably known as swarm technology. That was how it was called by Rand Corporation more than 10 years ago. The development of autonomous platforms working together with artificial intelligence according to algorithms created by military staffs. In other words, it is not machines deciding to kill human beings, it is algorithms written by human beings. But we are seeing just the very beginning at the moment in Ukraine. And this gives small countries, particularly the frontline states, the Baltic states, a genuine opportunity to defend our countries from the first centimetre. And let's be quite clear, another 50 years of Russian occupation and the Baltic nations probably would no longer exist. So we have to do it. We have to take this opportunity. And using this new technology, we can do things which the Ukrainians are managing now, where there is a 20-kilometer grey zone between the Russian and the Ukrainian forces for which to enter is extremely dangerous, and 5 Russians are dying for every Ukrainian. Traditional methods, of course, still have their role, but these new opportunities give us a chance, but they also, let us be fair, have given Russia a chance, because Russia is catching up with Ukraine, and we in the West are falling far behind. Well done to Latvia and the United Kingdom for starting off the drone coalition. The next summit will be next week, and I hope many of you will be attending. But the fact is that we are a long, long way behind Russia and Ukraine. And that has been demonstrated very clearly in the Baltic states and Finland over the last few days. But at the same time, let's remember that Russia is extremely weak. Weak because it doesn't have the manpower now, because it's lost nearly 1.5 million killed and seriously injured soldiers during the war. Putin is terribly afraid of the political consequences of mobilization, and he doesn't have the resources to be able to overcome the Ukrainian weaknesses, and therefore his economy is going down very, very rapidly. Now, what does that mean for us? We need to be thinking in terms of procuring these new weapon systems. But let's remember that NATO is a lady in her dotage. She is old. It takes her a long time to make decisions. And military thinking, with the exception of special forces, tends to be slow and tends to be about a decade behind civilian thinking. I'll give you 2 examples. Homosexuality in the armed forces, ladies or women in combat roles. Just 2 examples, there are many more. Now, what we need to be thinking about in terms of procurement is not waiting until the war in Ukraine is finished and then we'll buy up the best Ukrainian drones and anti-drone systems, stick them in a big shed somewhere, and when the Russians, when the Russians attack, we'll bring them out and then we'll be ready. No, because the technology is changing, if not day to day, it is certainly changing week to week. And that's the software, it's the communications, it is the electronic countermeasures and electronic countermeasures, and artificial intelligence. All of these things are really necessary. Therefore, we should be looking to develop not a system where we buy hardware but a system in which we procure a service which is updated all the time because of this essential speed of change. Now, what is the real threat? Well, Putin is averse to risk. You may not think so, but that is the way it has been since 2000. And he was persuaded by the FSB that winning in Ukraine with the forces he had available would be over in days or no longer than 2 weeks. Just knock on the door and the house will fall down. Of course, that didn't work out that way. But Russia is in no position to launch the same kind of attack on NATO as it launched on Ukraine in 2022. At the same time, I draw your attention to Assistant Secretary of State for Defense or War, whatever it happens to be at the moment, in the United States, Elbridge Colby, talking about NATO 3.0. Those who are not familiar with it, NATO 1.0 was immediately after the Second World War, when there was a serious Warsaw Pact threat. NATO 2.0 was when that threat went away because the Soviet Union collapsed, and we all thought, we're now going to live in peace, and we can concentrate on developing out-of-area operations. NATO 3.0 is something quite different. It is not simply a case of strategic autonomy, as some in Europe have talked about it, but it does mean that United States, whether under Trump or a Democrat president next, is not going to revert to the United States that we were happy to see paying for the majority of the costs of defending Europe. The Americans have said they are quite prepared to carry on providing a nuclear umbrella for us, which is absolutely essential. But conventionally, Europe, with a GDP, and I mean including the United Kingdom and Norway, with a GDP almost the same size as that of the United States, cannot expect the United States to fund its conventional defense against Russia as it has done in the past. That is why we see that American troops are being withdrawn, and we have got to get our act together in the same way as Poland, the Baltic states, and now Germany are doing. But other European countries have to do the same. It is often said that generals like to fight the last war, only do it better. Well, what was the last war? The one we are watching taking place in Ukraine at the moment. Therefore, if anyone really thinks that a Russian attack, whatever the reasons for it, against NATO would be the same as the attack against Ukraine in 2022, they're almost certainly wrong. We are much more likely to see a Kremlin organized subkinetic, or if you like, hybrid, possibly unattributable, certainly to start with, series of attacks which fall short of NATO's Article 5 and the European Union's Article 42.7, which are the two key articles which give us our defense when we are all sticking together. The aim, if Russia can get economic, political, or military control, for instance, of the Baltic states, that would be probably the end of NATO and possibly the end of the European Union. We've already seen attacks on Baltic Sea pipelines, whether they're deliberate or accidental. Some views differ. drones over airports, sabotage, energy has been mentioned, communications, they don't work without energy, and all kinds of other explosions, and indeed intimidation, assassinations. And I will draw your attention to the fact that in July 2024, Vadim Krasikov, a GRU now assassin who murdered a Czech dissident in the center of Berlin in broad daylight by shooting him in the back, was exchanged in an exchange with the West and greeted by Putin as a hero. And the message is quite clear. Russian special forces, go and do your nasty work against the West. We will get you back. Now, what are the deductions we should be making? First of all, against the subkinetic or hybrid measures, we need to have countermeasures ready. And that is certainly not beyond the wit and capability of European scientists. And we need to be proactive, because if Russia uses these kinds of methods against us, we must show them that there is a cost to bear. But of course, this also means that defense under these sort of circumstances is not just a question for the armed forces, but is the whole of society resilience. And that includes fire, rescue, ambulance, medical services, and absolutely critically, the critical infrastructure, which is what you are all involved with, especially energy, because without energy, nothing else works. Now, simple fact is, the army is too small to be in numbers to be able to protect critical infrastructure. There aren't enough National Guard soldiers to do it. You can't rely on civilian contractors, particularly if their background is Russian military in the past. Therefore, what? The answer is new technology, robotics, looking from above, being able to patrol on the ground with UGVs, and being organized remotely so that fewer people are involved, but the effectiveness is much greater. Then a quick word before I wind up with AI about hearts and minds. This is something that we used to talk about a lot during the Cold War. It is now called strategic communication, but it's the same thing really. But the consequences for government is that governments which throughout the West, including the United States and Europe, governments are not talking enough to the population, and therefore we're getting populist parties becoming much more effective on the far right and the far left. Disinformation is being used very effectively by Russia. Look at the first round of Romania's presidential elections. Cognitive war, in which I haven't got time to explain, but some of you will know, cognitive war is quite different from the disinformation. But the central role of cyberspace, which Biber will be talking about later on, is critical. I'll finish off very, very quickly, if I'm allowed, on the role of AI, particularly agentic AI. Agentic AI trained by you to do things the way that you would do it if you had 24 hours work capability every day throughout the year. The coordination of governments through artificial intelligence in all their functions is something which is inevitable in the next 2 to 5 years. Off-the-shelf solutions, ChatGPT 94 is not going to be the answer, because to get to what you really need, you need years of work, you need millions in investment, and you need programmers. Data sovereignty. Do you really want your most closely guarded secrets to be open to Peter Thiel and Palantir and his friend in the White House? Probably not. EU conformity, very important that we should be able to deal with our threats according to the legislation which applies within the European Union. And last but not least, compatibility with existing systems. Almost certainly every ministry in Latvia is using AI to some extent or other. Question is, how can all of this be brought together and made compatible so that when the intelligence services find something out important which matters to the Ministry of Defence, the Ministry of Interior, it will almost certainly matter also to the Ministry of Economic Affairs, to the Ministry of Transport, communications, energy. A lot of people need to know this. How do you get this out? And the bottleneck is availability of suitable hardware, especially GPUs. There is now a long waiting list, and if we don't get on that waiting list pretty damn quick, we are going to be falling behind. On that happy note, I would finish with just to say what is important is that we stay united, particularly within Europe, that we hope for the best, that we prepare for the worst using new technology where appropriate, or to use the old Roman phrase, civis pacem para bellum. Thank you very much.
Ladies and gentlemen, Jānis Kažociņš. Thank you very much, Mr. Kažociņš. Very strong open to our conference, and let me stick to English, because this is an interconnected world, and we are dependent on so many things, many systems included. And what happened in Spain and Portugal last April, it was not just a local happening, a local disaster. It was actually a warning to each and every grid operator in Europe, including us. And our next speaker, he works with technology, and he actually builds technology that helps grids prevent this exact danger. He has spent his entire career actually in the energy transition sector, starting from Siemens Gamesa to Vattenfall, and since 2022 he co-founded Plexi Grid, a company that optimizes how electricity networks are planned and operated, making grids smarter, making them more flexible and resilient. And if the name Plexi Grid seems somewhat familiar, you're not wrong, because they are already working together with Sadales Tīkls. So let's welcome on the stage the CEO and co-founder of Plexi Grid, Alberto Mendes Rebollo. Welcome, Alberto. Welcome to Riga.
Such a beautiful city, really. I arrived yesterday afternoon and I enjoyed a really nice walk about this time of the year is really special. And well, I want to know some things about the audience. How many electrical engineers? Raise your hands. Okay, about 1/3. Any TSO? Okay, a few hands. And DSO, rest is DSO, I guess, right? Great. It's good to know. The ones who didn't raise the hand, do you want to share what you do? Are you economists or lawyers? Economists? No? Okay, interesting. And lawyers? Okay. Is it media here? Any journalist? And can we have Chatham House rules? Or in other words, do you really want to know what really happened in the blackout? or the official version? Official version, raise your hands. Okay, so we take well, my co-founder and the genius behind the PlexiGrid technology, Pablo Arbolella, he's one of the best electrical engineers in the world. He's been awarded Outstanding Electrical Engineer of the Year in December 2022 for the design of the PlexiGrid technology from IEEE, so it's the Electric Oscars. And he will do a much better job than me, but he couldn't make it today, so I'll try to do as good as I can. But the Spanish Senate conducted an independent investigation, and he relied on 2 national experts to really find out what really happened, and Pablo is one of these 2. So we got access to a lot of information. But if I had to summarize it, I will do it with systems theory. Remember, systems theory originates in biology, and then it's been later on adopted to the design of engineering systems and control systems. But what the systems theory says is that if the speed of change in the environment of a system is going faster than the ability of that system to adapt to that change, you will experience system instability. And if it prevails over time, you will experience system failure. And that's exactly what happened, basically, on this day. In other words, we built Grid 1.0 over 100 years ago for an energy system with large, centralized, dispatchable power plants with very predictable, unidirectional, one-directional power flows from the large power plants to the cities to the households, right? And then we start this energy transition, which is one by one exactly the opposite. We go from central to distributed. We have hundreds of millions of solar panels, batteries, electric vehicles, heat pumps, air cons. We have extremely complex bidirectional power flows. And we've been working with the most complex grid operators in the world, with the Australians, with the Nordics. Spain has quite a bit of renewables. You have intermittency from renewables. You cannot dispatch up and down the sun and the wind as you can with a hydropower plant or a gas plant. And so, you know, everything that is connected to your grids is changing at the speed of light 180 degrees different than the original design parameters from Edison. And no wonder, you know, you will experience some of these system instabilities. And besides the Spanish blackout, we've seen a huge amount of problems in Australia, in New Zealand, in the Nordics, in Southern Europe. Well, in Spain, we have a whole Catalonia blackout. Catalonia is 7 million people, right? So it's bigger than many European countries, but it didn't make the headlines. In Italy, as you know, recently there was another regional blackout, quite big, quite scary. And then there is also blackouts coming from sabotage, right? Like the Berlin blackout, where they lost a whole section of the grid and it took them a few weeks to put it back. So we are seeing, besides the Spanish blackout, which was big and spectacular, but we see a huge increase in the frequency of smaller blackouts. Now let's get a bit technical. So all of this luckily happened on spring. It was spring day, 20 degrees minimum consumption. That's when we consume the least through the year. But the electrical engineers in the room, probably you know about the Ferranti effect. So when you have very little loaded power lines, the capacitance on the transmission lines, on long lines with very little load, become capacitive, and they start producing reactive power and pushing up voltage. It's a little bit of a nightmare. For the non-electrical engineers, we normally talk about active power is like the beer, and reactive power is like the foam of the beer. You should have just a little bit, but not too much. But what happens when it's very little loaded is there is no beer, but there is all full of foam, you know? And this is a massive problem, because then you start to have overvoltages and oscillations. Then the TSO and the procedures say, and that's for all TSOs pretty much around the world, and of course in Europe, before you stabilize voltage, you need to stabilize oscillations. So first of all, stabilize oscillations. So they are battling, trying to stabilize these oscillations. By the way, funny thing is, as you know, some of these oscillations, they travel through Europe all the way to the Baltics, from Portugal to the Baltics and then back, these pendulum oscillations. That's also quite interesting. And I was thinking about we're a peninsula, but I was looking at the map as well, so there's a lot of things of common with the Baltics, because after you disconnected your grid from Russia, and with Putin sabotaging your offshore interconnectors to Finland and so on, you look very much like an electric peninsula now. If you look at the connectivity, right? You are an electric peninsula. So, yeah. So the next thing that happened, and I come back to one picture because otherwise I could talk here hours about this. I will take only one slide that summarizes it all. But in trying to prioritize oscillations to stabilize the system, you are not prioritizing overall voltage control. So voltage starts to go to quite a high level. This is all coming from rooftop solar. Okay, I asked how much gigawatts you have. I think you have 1 point something gigawatts of renewable, right, in Latvia. And a big part of that is solar. In Spain, we have 17 gigawatts of solar and growing. And almost half of that is in a rooftop, in the roofs of people. There's 7 or 8 nuclear reactors in the roofs of people. That's difficult to understand. But it is like this. And it was a shiny day, so a lot of that power was also shooting, right? Also contributing to these over voltages, because as you know, when you inject power on a grid, voltage goes up. So this is a little bit the context. You know, so a very inoffensive, easy day of spring becomes a little bit of a nightmare. And they are battling for a few hours, you know, these oscillations. And then, let me tell you, well, the scale here, I don't know if laser, right? We have laser, great. 50, this is seconds, right? 5 seconds, 5 seconds. So every little of this one is a second. See how everything goes to hell in a few seconds. But the background before, it tells you that how we got here. How on earth do we have the transmission system at 430,000 volts? You know, here, as you know, we need to stay between plus minus 10%, so normally it should be in 400 kV. They're at 125,000. But that's because they have been focusing on battling oscillations. Then an extremely funny thing happens that on the Ferranti effect, normally, on a normal system, when you inject power, voltage goes up. And when you disconnect power, voltage goes down. So as some trips will disconnect, voltage should drop. But not when you have Ferranti effect, because you're taking beer and it's only the phone left, and that's pushing, it's pushing more and more reactive power into the system. You have a big capacitor all of a sudden on all these unloaded plants, and the more these unloaded lines, and if you take more plants, you are taking beer, right? But you're leaving the phone. So you see here, this bump here, a plant disconnected, and normally voltage should go down, but it keeps going up and up. So these disconnections that are happening, and this is in distribution, right? So you have over voltage coming from distribution, but because of resistance, here you are at 1.8, for example, of maximum, but in distribution you pass already 1.8 and 1.1, and I come back to that. The biggest cause of the disaster was the setup on all the PV inverters. We have 17 gigawatts of PV inverters, and the procedure is that when you get to 1.1 in voltage, nominal voltage, disconnect to protect the grid. But that procedure was set nearly 20 years ago, when we had 400 megawatts of solar. Okay, so some disconnections happening. Because of Ferranti effect, voltage keeps going up, so here there's some solar packs that already went to the 1.1, and at some point here, you get to cross this line of 1.1 at transmission level. That means that pretty much the rest of the country is certainly about 1.1 because you are injecting a lot of power from solar. up here, there was a lot of speculation that we have inertia problem. Let me tell you, the problem in Spain was not an inertia problem. So here, up here is the 50 hertz, right? To the 50 hertz. So in green is the frequency of Europe. And in blue is the frequency of the Spanish peninsula, Spain and Portugal. You see, it works like Wonderline. Because of this here, it creates a little bit oscillation, but it's not a problem, you know what I mean? It's holding quite fine, the frequency. But here, things start tripping. You know, you have a lot of overvoltage. So in these seconds, in reality, that's 10 seconds. And in most, and especially here, which is not even 5 seconds, we lost 17 gigawatts of power generation. Literally, the DSO had an N-20 event in seconds because all this solar just disconnected. Why? Because it was programmed to do so. You can blame the solar panels, but they did the work. They were told, you know, the problem was the algorithm, the control, not, you know. And so, number one recommendation, never set this up like this, you know. You can have ball bar setup, and even better, a full voltage control setup. Because the funny thing is the power electronics of these devices, they are equipped to actually control and help. They could have been helping. They could be consuming foam and injecting beer on the glass. So they could have been helping. But for that, you need to set them up and connect them to the DSO and to the TSO. And so, yeah, here you see, boom. And here, by the way, things start to go to hell, and you see this bump here. That's when the French cut us off. Because if they don't cut us off, it will have continued through France and Germany. And look what we created to Europe, right? We moved the frequency of the whole of Europe. So if the French don't cut us off, the French TSO, this would have been a bloody mess. And the last thing is that the control systems for the TSO, the derivative of frequency controls didn't act correctly because they are also set up for the centralized system. And nobody has recalibrated these setups in years, but we have a very different energy system. So it was basically a question of control. Now I want to use I don't want to be depressing, but let's go to solution mode. But we are developing control down to, this is like TSO view, but at the street level. So power flows, state estimation, down to street level. This is what you need to have. If you want to have a transition system, you need to have control. It doesn't work with the old systems. Sorry, here we have, if we can. Of course. Can you play the video here? No, it doesn't work. Well, here we have, if we go to one of the substations, right? And here the same. Have problems to see the video, right? Now it's playing. We're gonna go to one of the substations, and super quickly, this is just 1 minute, last minute, and we can see this is in distribution, low voltage. We see on the morning we're fine, but in the evening we're gonna have a huge overload unless we do something about it. And we have, with a number of DSOs now, the capability to have full control on all the DERs, which are down there registered on the local flexibility market, okay? Flex connections. And then what you have is here, our machine automatically is telling each of these devices what to do through a local flexibility market. And then you have end-to-end control of everything that is going on. This is also in distribution where we can see perfect control down to low voltage, like a TSO SCADA, but on distribution. And well, with this system in place, we could have been controlling perfectly and avoided this blackout or many other things. This is a control room version of our system, which we just inaugurated last week in Spain. And this control room can be connected. We had a discussion before with your head of the TSO. We are working a lot on the TSO-DSO coordination because sometimes there are things happening in DSO that are destabilizing the TSO and vice versa. Distribution used to be just impedance, a very simple system. Now, distribution is immensely complex, more complex than transmission, and so you need to have this TSO, DSO. In Spain, we have a saying that where the firefighters are fighting a fire, they should not be stepping in each other's houses. And we are seeing that between transmission and distribution. Because the right hand doesn't know what the left hand is doing, there are some involuntary actions that the TSO take that can create problems on distributions and vice versa. So it's extremely important to create these real-time synapses to create this end-to-end visibility and end-to-end control. So yeah, energy transition is a brilliant idea. I know that you guys don't want to rely on Russian gas. Renewables are super cheap, so power generation is working really well. Solar and wind is the cheapest way to produce power. You have the natural resources, but if you don't adapt your grid for that, you have a problem. The good news, and that's the last thing, is that once you have done this for renewables, it's immensely well prepared for resilience, what we call distributed security of supply. So now NATO and European Defense Agency have asked us to create a dual-use version of our system for distributed security of supply and islanding. We have developed this with Vattenfall in 2 islands, the island of Arholma and the island of Gotland, and it allows that these islands are connected to the shore, so they are powered from the shore, but they have local production of renewables, but if you cut the cable, the whole thing collapses, but not with our system. We have already commissioned it in Arholma, we stopped the cable, and it can run in island mode. You can have this also in continental Europe. So for example, if Berlin grid, Stromnetz Berlin, would have had this system, to the same sabotage, they could have run this section of the grid on island mode. You don't have perfect service system, but it's a lot better than a full blackout. And if you look about Ukraine, they've been immensely resilient, as you say, but the Achilles heel of Ukraine was the electricity grid. That's where really Putin has put these guys on the knees. And so if you build a distributed system with batteries, with renewables, and with an AI-powered brain that can allow this kind of distributed security of supply to the same aggressions, when they blast a drone blast a substation, they just make a scratch to you. You know what I mean? So I think the direction of travel for Europe, I think, is clear. We need to develop this AI that gives perfect control on the grid for what's good for energy transition reasons is also good for resilience reasons and for energy independence reasons, right? So, well, I hope you liked it and happy to engage on the coffee break if you have any more questions.
Alberto, thank you. Thank you very much. I won't bother you with questions as we will meet in the panel discussion afterwards, but what I understand as a non-professional, not enough beer, that's a problem. Too much beer, also a problem. So just drink sangria and you'll be good. All right, moving to case number 2. We heard about military attacks, cyber attacks we're going to hear about. We heard about technical problems, but there's a power that is far greater than everything that we talked about, and that is nature. We just can't, as humans, as systems, really affect what happens globally. We can just adjust our systems and learn from what has happened. And already mentioned, Storm Iwan in Ireland was one of the most powerful storms in the recent decades that the British Isles have seen, and our next speaker was, well, not literally, but at the center of all of that, but at the center of response. She's ESB Networks, which is the Ireland's electricity distribution system operator. It's a storm review manager, and she's the one leading the review of what happened, what worked, what didn't work, and what needs to change so that the next storm is just a breeze in our hair, so to say, not a problem for our systems. And she comes to us with a lot of lessons learned, which we can learn from as well. Let's welcome on the stage Karen McJoe. Welcome, Karen. Welcome to Riga.
Thank you. Good morning, everyone, and thank you for the invitation to speak today at this very interesting event and very nice location. And as I was coming up, I walked from the security through the really nice tree-lined area. I was looking at the trees and thinking, they're really, really beautiful, but in times of storm, they're not always our friend. So we might talk about that a little bit more later. So I'm here today to talk about Storm Éowyn. It was the most severe storm the country has experienced. And look, it's not just a weather event. For us, it really tested our preparedness, stress tested our preparedness and our assumptions. So I'll talk a little bit about that, and I'll also think about, I am looking back, but we're also looking forward. So how do we prepare for the next event? So just if the clicker's working, just to put us, for those that don't know, here we are on the west of Europe, facing into those wild Atlantic winds, let's say. And ESB Networks is the electricity company in Ireland. We are the TAO, the DAO, and the DSO, and we work very closely with EirGrid, who's the TSO. And I won't go through all the statistics, but you'll see that we have a very large overhead network from the transmission all the way down to the low voltage. And the weather in Ireland and Latvia might be somewhat different, but I think we both have those challenges of that overhead network experiencing some extreme weathers. So into Storm Éowyn, it was the most severe storm that we have experienced. It came with gusts of 184 kilometres, and that impacted almost a third of our customers. 768 customers were affected at the peak. And you can see the timeline for the restoration. There was many customers that were out for long times. The other thing to note in this graph on this side, at one point our whole country was in red weather alert. And also the three storms that are underneath Storm Éowyn, Storm Dara was the next most impactful, and that actually happened less than 8 weeks before Storm Éowyn in December 2024, so that's not shown. And again, stress testing our assumptions. No storm presentation would be complete without some photos, and there's been many, many published. And this is just a sample of them, just to give a sense of the damage and the conditions. And anyone that's been involved in a storm restoration, I'm sure these are very familiar, particularly if there's a lot of trees and forestry that we have to deal with. What followed was a national scale response. So we took every single tool out of the toolbox to get the customers back, managing the safety. We had over 3,000 crew members on the ground, supported by over 1,000 people. And that support is really important, because in order to be able to bring the amount of people in on the ground, you need all of the people behind the scenes in really critical roles. The damage assessment, which is a key part of any restoration, we had many thousands of people on the ground doing the damage assessment. We had drones, we had helicopters, like significant damage. That followed with significant restoration, vegetation clearance, forestry, 50 forestry harvesters. And then we had millions of interactions with our customers, all channels, the phone, telephony, social media. And on this side of the graph here, you can see some countries that helped us. And normally in our restoration efforts, we would go to our nearest neighbours, so Northern Ireland, UK, France, and we have shared mutual aid in those times of need. But for Storm Éowyn, we knew that this was going to be on a different scale, and also Storm Éowyn happened. It also crossed Northern Ireland and the UK. So those utilities were also in storm restoration. They did absolutely provide us with help, but they needed to get their own restoration fixed first. So we put a call out to EDSO, the European DSO, for the first time, and the response was overwhelming. We had instant response, and in total we had about 650 people come in from outside Ireland to help us with the efforts, which is really, really significant. So this is really a complex management of a lot of different factors: safety, operational efficiency, logistics, hotels for all of these people all around the country. And the structures did work. They were scalable. They were able to bring in all these people, so they did work. And it was mentioned that I've been carrying out the review of Storm Éowyn, and we have since published a number of documents. We're currently about to publish the output of a review that we're undertaking, looking at other not just European, international utilities and what they have done in the aftermath of large storms. So we will publish that very soon. And I think we've done a lot of looking back, but now we have to start looking forward and how do we really prepare? And the big question we're asking is, are we preparing for another storm Aeon? Or what is it that we're preparing for? What are the credible upper ranges of the future events? And green line here is our line of 184 kilometers. But what's notable and important to see is that these weather events aren't isolated. You know, they are happening. So how do we really plan for this? Like planning for wind speeds with a network that serves quite a large dispersed rural population with overhead network to wind speeds of 140 kilometers, that's one thing. And then if you think about designing for 180 kilometers, that's another situation. But then beyond that and over 200 kilometers, which is what we've seen earlier this year in Portugal and France, that's fundamentally different. So how do we begin to think about how do we prepare for that and the time and investment that's needed, importantly, which ultimately our customers need to, will be conscious of. So what we're doing in ESB Networks is using that definition of resilience. So for those that might not be familiar, so resilience as defined by IEEE and others is the ability to withstand, adapt and recover. And it's normally shown in this kind of graph of a timeline of event. I'm showing it here in a bit of a continuous loop because we do feel that it's more of a continuous and adaptive process. And absolutely, we're looking at the first of the four R's, okay? The first of the four R's is robustness under this definition. So that the ability to withstand that event. And absolutely, we have measures, vulnerability assessments, interventions, both in hardening the network, vegetation management. But then as we move around, it is important that we don't put all our dependency into over here. We have to, at the same time, look around the curve of the resilience. And in terms of redundancy, we talked about communications. Thankfully, our communication systems in ESB Networks during Storm Aeon worked really well internally. But we have all of our communication to our SCADA is on a private network predominantly, which worked really well. I'll talk a little bit about the learnings on dependencies on private comms. So focusing in on targeted automation schemes in the event that the damage will happen, how do we have redundancy built in? And then again, even if the redundancy fails, there will be customers impacted. How do we fix them really fast? How do we identify where exactly the faults are? And then at the end over here, how do we look at that prediction? How do we understand with the data that we have using impact prediction, how do we really start to look at how we can build all of these together to create resilience? And if I just talk about the key kind of findings from Storm Aeon, there was kind of, I'll summarize it into four things. The first one was situational awareness. And that's that whole piece around understanding the vulnerabilities and then also trying to understand what's happening at that time. So that prediction of the weather, it's great, it's getting better, the forecast, but they're not always really accurate in terms of the severity, in terms of the location, the timing. So bringing all of that together is really important. And the second thing, and it was discussed earlier, critical infrastructure dependencies and interdependencies. So our services, emergency services, health, water, telecommunications, all rely on us. They rely on our services, but equally, we rely on them for our restoration efforts. So this interdependency was completely evident during Storm Aeon. And that is something to put to the front. And in that end, we have led, through EDSO, a working group whereby we're looking at resilience, okay? There's resilience, and what that means, and interdependency of critical infrastructure is coming through. The third point is around the mutual aid. Huge support, as I described, from European countries. And like really, it was so crucial during the restoration to help us, and how everybody really had the same commitment and like intention when they landed from very far countries, Norway, Finland, onto Ireland. And to that end, we have been working with EDSO and led a working group to put in place mutual aid agreements. That was signed off earlier this year, and it's like a framework for mutual aid which allows utilities, member utilities of EDSO, to now put bilateral agreements in place with each other, which again strengthens that working relationship across Europe. And finally, the customer. The customer, absolutely safety, public safety and customer restoration key. But the other piece that came out of our review was communications and the importance of timely, accurate and regular communications, not just during the storm, before the storm, during the storm and after the storm. So just to conclude, really what we're trying to understand is how do we work in a very unpredictable future in terms of resilience. And like we can't predict with total certainty. We can't design for every eventuality, and we can't remove all of the risks. I suppose what we're saying here is that we can plan for plausible futures, and looking at that resilience across all the 4 R's, we endeavour to continuously improve for our customers with the right investment levels, a more resilient electricity network. Thank you.
Thank you, Karen, and we will see you later on in the panel discussion that will follow. Thank you, Karen. Dāmas un kungi, turpinām ar mūsu nākamo runātāju, un tikko dzirdējām stāstu par vētrām. Latviešiem patīk novērot dabu, sekot līdz dažādām norisēm. Kā mēs te tādā cilvēka līmenī izejam vienkārši pļavā, kā mēs varam novērot, kad vētra tuvojās? Ir kaut kādas tādas sentēva atziņas, kad zinām. Klusums, jā, putni beidz dziedāt, vai ne? Kukainīši mēdzot nolīst zemē kaut kur apakšā, ja? Mājlopi kļūstot nemierīgi, tā arī esot laba pazīme. Daži skatās koku galotnies, dažiem tā īpašā smarža gaisā, tas ozons ir sajūtams. Mēs pēc kaut kādām pazīmēm, kas mums apkārt, mēs redzam, mēs aptuveni saprotam, tagad varbūt, ka ir jānolien nedaudz drošākā vietā, bet ir vēl viens apdraudējums, kurš ne smaržo, ne kliedz, ne brēc, ne blīkšķ. Un tas, protams, ir kiberuzbrukums. Kiberuzbrukums un hibrīdu uzbrukumi, par kuriem jau Kažociņa kungs runāja arī pašā konferences ievadā, un nav jāmeklē tālu. Pat neseni virsraksti liecina par to, ka ASV krastos uzbruka vienam no lielākajiem enerģētikas infrastruktūras milžiem Aitronu ar viņu mājsaimniecības uzskaitas ierīcēm, kas aptver ļoti lielu cilvēku skaitu. Un kāds teiktu, bet tas jau pavisam tālu, viss kārtībā, tas mūs neskar. Nav nemaz tajā savienotajā pasaulē, nemaz tas tik tālu. Tas patiesībā ir viens no virkni no gadījumiem, kas ir notikusi, kas apliecina to, ka kritiskā infrastruktūra un tā skaitā arī energoapgādes sistēma ir viens no kiberapdraudējuma galvenajiem mērķiem. Un šodien ar mums ir cilvēks, kurš par to zina iespējams labāk kā jebkurš cits šajā istabā. Viņš ir viens no Latvijas kiberdrošības aizsardzības pīķiem, varētu tā izteikties, Certa.lv vadītāja Baiba Kaškina. Sagaidām ar aplausiem. Sveicieni, Baiba. Laipni lūdzam. Ček. Jā, redz kā. Gadās arī tā.
Labdien visiem! Labdien, kas šajā zālē un tie, kas mūs skatās attālināti. Un liels paldies par iespēju parunāt par to, kāda ir kiberdrošības nozīme kritiskās infrastruktūras aizsardzībā. Mēs dzirdējām jau par to, kādi apdraudējumi nāk no gan pašas enerģētikas puses, gan no laikapstākļiem, bet kiberdrošība ir kļuvusi arvien klātesošāka jebkurā mūsu dzīves jomā, tā skaitā, protams, kritiskajā infrastruktūrā. Ja mēs skatāmies uz digitālo apdraudējumu realitāti Latvijā, kāda tā ir pēdējos gados, tad, diemžēl, tendences ir augšupejošas, apdraudējums ir augsts, pastāvīgs un kāpjošs. Ja mēs skatāmies uz pēdējiem ceturkšņiem Latvijas kibertelpā, tad tas ir vēsturiski augstākais apdraudējums, kādu mēs esam redzējuši. Šeit jūs redzat bildi no 22. gada, kad sākās pilna mēroga uzbrukums Ukrainā, un tātad sarkanā līnija oranžā ir tā, kur ir manuāli apstrādāti incidenti. Zilā masa ir tas, ko mēs redzam apdraudētas iekārtas mūsu kibertelpā. Šī līkne, protams, nav saistīta tikai ar iekārtu palielinājumu, bet arī ar to, ka mēs iemācāmies vairāk redzēt, vairāk atrast un zināt. Bet kopumā redzam kopējo bildi. Ja salīdzinām ar laiku pirms 22. gada, tad apdraudējums ir audzis 6 līdz 8 reizes atkarībā no sektoriem, atkarībā no dažādiem incidentu veidiem. Kas ir tas, kas mums uzbruk? Kuri aktieri vai uzbrucēji ir tie, ko mēs redzam savā kibertelpā? Pamatā, protams, tie ir finansiāli motivēti uzbrucēji. Finansiāli motivēti uzbrucēji, kam interesē mūsu nauda. Bet tikpat klātesoši un bieži vien stāvošais lielākiem un nopietnākiem incidentiem ir citu valstu sponsorēti uzbrucēji. Būsim atklāti. Krievija ir galvenais apdraudējums mūsu kibertelpā. Tā tas ir bijis arī pirms 22. gada, un tā tas ir pilnīgi noteikti kopš 22. gada. Mēs redzam visdažādākos Krievijas grupējumus, veicot operācijas mūsu kibertelpā. Diemžēl pēdējos gados redzam arī daudz operācijas, aiz kurām stāv aktieri, kas varētu būt saistīti ar Ķīnu. Un atšķirās mazliet šo uzbrucēju intereses. Tātad tie, kas ir vairāk saistīti ar Krieviju, parasti izvēlas kritisko infrastruktūru, valsts iestādes, arī jūsu sektoru. Ķīnai savukārt ir liela interese par akadēmisko pasauli, par zinātniekiem, par mūsu pētījumiem, bet kopumā apdraudēti esam mēs visi. Un vēl tendence, ko šeit gribētu pieminēt, ir tā, ka piegādes ķēdes ļoti bieži aizved mūs uz Ķīnu. Tāpat arī ārpakalpojumu sniedzēji ir veids, kā ārējie uzbrucēji mēģina atrast ceļus, lai piekļūtu mūsu sistēmām, nostiprinātu savu klātbūtni tajās un varētu rīkoties tajā brīdī, kad viņiem tas būs izdevīgi. Kāda ir situācija Latvijā salīdzinot ar Eiropu un pasauli? Ar visu pasauli būs grūti salīdzināt, bet katrā ziņā ar Eiropas Savienības un NATO valstīm mūsu kibertelpa ir diezgan līdzīga. Viņi tāpat novēro ļoti augstu apdraudējumu līmeni, līdzīgas tendences, bet arvien biežāk mēs arī tāpēc pamanām dažādus virsrakstus starptautiskos portālos, dažādās ziņu grupās par to, ka kiberincidenti ietekmē reālās dzīves notikumus. Piemēram, Beļģijā slimnīca bija jāevakuē, tāpēc, ka bija izspiedēja vīrusu uzbrukums un pacientus vairs nebija iespējams ārstēt, izmantojot tehnoloģijas. Tāpat arī uzbrukums Polijas elektrības sistēmai pagājušā gada decembrī, par ko es mazliet vēlāk pastāstīšu sīkāk. Lai cik drūma šī bilde izskatītos, labā ziņa ir tā, ka tiešām Latvijas kibertelpa turās ļoti labi, jo visi incidenti un lielais viņu skaits nav radījuši tādas sekas, kas būtiski ietekmē sabiedrībai svarīgu pakalpojumu funkcionēšanu. Ne līdz 22. gadam, ne pēc nav bijis tā, ka kiberuzbrukuma dēļ mēs ilgstoši neesam varējuši saņemt kādus no svarīgajiem pakalpojumiem. Tātad noturība mums ir labas iestrādnes, bet mums ir jāturpina strādāt šajā virzienā un tā trenēt. Mazliet par tendencēm un taktikām. Varbūt, ka tās jums liksies ļoti tādas triviālas un primitīvas, ja runājam par kritiskās infrastruktūras aizsardzību, bet atcerēsimies, ka katra incidenta sākums ir kaut kas vienkāršs un triviāls. Tas ir vai nu darbinieks, kas uzklikšķina uz kāda saites vai atver kādu pielikumu, ko nevajadzētu. Tas var būt neatjauninātas iekārtas un citas sīkas kļūdas, kas noved pie lieliem incidentiem. Tātad pirmā tendence ir krāpniecība. Tas ir viss, kas saistīts ar smikšķerēšanām, pikšķerēšanām, viltus zvaniem, visiem pārējiem veidiem, kā krāpnieki mēģina tikt pie mūsu naudas. Paralēli viņi tiek arī pie mūsu datiem. Ne tikai nauda, bet arī dati ir nauda. Ja skatāmies uz zaudējumiem, tad pēc Finanšu nozares asociācijas datiem pagājušajā gadā no 4 lielākajām bankām tika izkrāpts vairāk par 12 miljoniem eiro. pieliekot klāt datus no valsts policijas, tie bija gandrīz 24 miljoni eiro, kas tika pazaudēti dažādās krāpniecības schēmās Latvijā. Labā ziņa šajā bēdīgajā stāstā ir tā, ka novērsti tika gadījumi par 14 miljoniem. Tātad novērsto gadījumu skaits 4 bankās bija lielāks nekā pazaudētās naudas apjoms. Bet citādi pa gadiem redzat, ka diemžēl pazaudētās summas tikai kāpj. Kādas tad ir tās svarīgākās piekoptās taktikas? Diemžēl pirmajā vietā šī gada pirmajā ceturksnī ir investīciju krāpšana, kas pārliecina cilvēkus ieguldīt viltus investīciju vietnēs. Un otrajā vietā ir tātad viltus reklāmas Google meklētājā. Cilvēks meklē valsts ieņēmumu dienestu, nonāk viltus vietnē, zaudē savus datus un naudu. Par investīciju portāliem droši vien gandrīz visi esat uzdūrušies kliedzošiem virsrakstiem, kas izvietoti vietnēs, kas ļoti atgādina zināmus portālus, Delfi.lv, Jauns.lv, citus, un visbiežāk pēc tam noved pie vietnēm, kas aicina cilvēkus ieguldīt naudu. Otrā tendence ir saistīta ar tieši ļaunatūrām un ievainojamībām, pateicoties mākslīgajam intelektam, kas jau pāris reizes no skatuves ir šodien pieminēts, tiek atklāts arvien vairāk un vairāk ievainojamību visās programmatūrās, ko mēs izmantojam. Tas savukārt noved pie ļoti liela izaicinājuma šo programmatūru atjaunināšanā un arī dod iespēju uzbrucējiem izmantot šīs ievainojamības neredzēti straujā tempā. Tāpat trešā tendence, ko gribētos pieminēt, ir piekļuves pārņemšana. Tātad esam redzējuši ļoti daudz gadījumus, kur uzbrucēji atrod veidu, kā apiet gan divfaktoru autentifikācijas, gan citus aizsardzības mehānismus, pārņemt Microsoft un Amazon kontus, piekļūt jūsu datiem, kas glabājas mākonī, un tālāk jau dažādi uzbrukumu scenāriji ir iespējami, vai tie ir izspiedēji vīrusi, vai jebkāda cita veida uzbrukumi. Bet parunāsim par apdraudējumu tieši operacionālo tehnoloģiju vidē. Tātad OT ir kaut kas cits nekā IT. IT ir mūsu telefoni, datori, serveri, mājaslaps, tas, par ko mēs esam pieraduši runāt, domāt, aizsargāt. OT vide ir pavisam citas iekārtas. Tās ir iekārtas, kas tiek izmantotas tehnoloģiskos procesos, tās, kas tiek izmantotas ļoti plaši energo nozarē, gan pie ražošanas, gan pie pārvades, gan citur. Tāpat viņas tiek izmantotas jebkuros citos ražošanas procesos, ūdens apgādē, kanalizācijas attīrīšanā, piena rūpniecībā. Tātad OT iekārtas ir parasti maziņas iekārtas, kuras arī ir pieslēgtas tīklam, kuras arī dzīvo vienā tīklā ar mums un kurām, ja viņas ir tīklā, var uzbrukt. Tas arī noved pie stāsta par uzbrukumiem Polijā pagājušajā gadā. Pēc analīzes skatoties jau notikumu schēmu, redzam, ka gatavošanās šim uzbrukumam bija sākta pagājušā gada pirmajā pusē, bet uzbrukums tika realizēts decembrī, ziemā, kad ir augstāks, cerot, protams, nodarīt lielāku postījumu, un informācija par to tika publicēta šī gada sākumā. Tātad uzbrukumi bija vērsti pret atjaunojamo energoresursu ražotnēm, gan saules, gan vēja parkiem, tāpat arī siltumu un elektrostacijām, un uzbrucējiem pilnīgi noteikti bija kaut kādas zināšanas par operacionālo tehnoloģiju iekārtām. Viņš zināja, kā tās atrast un kā tās var ietekmēt. Tāpat arī diezgan skaidra bija uzbrucēja saikne ar elektrumu draudu grupu, kas ir asociēta ar Krieviju. Mērķis bija ietekmēt šo iekārtu attālinātu uzraudzību un vadību. Tātad tās, kas ir remote terminal unit iekārtas lauka apstākļos, tika skartas, tika pārrakstīta viņu pamat programmatūra, jeb firmāra, un paralēli notika uzbrukumi arī IT sistēmām ar disku pārrakstīšanu, serveru raidu masīvu iznīcināšanu, izmantojot Viper malvāri un citiem mēģinājumiem. Kāds rezultāts tika sasniegts? Diemžēl tie bija plaši sistēmas iekārtu bojājumi, tika pazaudēta kontrola un redzamība par iekārtām, bet labā ziņa, ka nebija tiešas ietekmes uz energoražošanu. Tātad šis pēdējā laikā ir tāds akūtākais incidents nozarē, kas, protams, daudz tiek arī pētīts un analizēts, lai novērtētu tā ko darīt, lai tas neatkārtotos pie mums un citur. Par operacionālajām tehnoloģijām CERT.lv domā jau ilgi. Mēs gandrīz 10 gadus strādājam šajā virzienā kopā ar Latvijas enerģētikas sektoru, kopā ar citiem sektoriem, piemēram, transportu, ūdens apgādi, un kopīgi mēs veidojam arī operacionālo tehnoloģiju drošības centru, drošības operāciju centru, lai varētu labāk pamanīt apdraudējumus OT vidē, informēt tos, kas ir potenciāli apdraudēti, un šos apdraudējumus novērst. Viena no lietām, ar ko mūsu inženieri nodarbojās, ir tieši meklēt iekārtas, kas ir nejauši palikušas redzamas internetā. Parasti iekārtām ir tātad web saskarne, kuru mēs mākam nodrošināt, uzlikt tai drošu paroli, rūpēties, lai tā nav viegli sasniedzama, bet šīm mazajām OT iekārtām ļoti bieži atvērti ir arī citi porti tīklā. Un, ja uzbrucējs zina, ko meklēt, viņš var atrast šos portus, ar tiem iedarboties, mainīt konfigurāciju, resetot konfigurāciju un ietekmēt reālus procesus. Viena no mūsu aktivitātēm ir tieši šādu iekārtu meklēšana un pēc tam rūpēšanās par to, lai tiktu atrasts iekārtas pārvaldītājs, īpašnieks un iekārta tiktu drošināta, lai viņu nevar ietekmēt attālināti. Šādas darbības, protams, paņem laiku un resursus, bet es domāju, ka kopā mums ir ļoti labas iespējas panākt situāciju, lai Latvijā nevarētu tikt realizēts Polijas gadījums. Kopējie secinājumi, kā jau iepriekšējie runātāji minēja, uzbrukumi kļūst hibrīdi, tie izmanto gan tehnoloģiskās, gan cilvēku ievainojamības, un tāpēc arī noturība ir jāveido daudzslāņaina. Nepietiek tikai ar tehnoloģijām, kas mūs aizsargās, ir jāizglīto cilvēki, jārūpējas, lai ir organizacionālie procesi vietā un operacionālā darbība arī. Tāpat par OT iekārtām, ja tās ir pieslēgtas tīklā un sasniedzamas, tām var uzbrukt. To mēs nedrīkstam aizmirst arī tajā brīdī, kad mēs apzinām un uzraugām savu saimniecību. Ko tad es varu darīt? Kā jau minēju, pirmais solis ir, protams, apzināt un uzraudzīt, kas mums ir, rūpēties, lai mēs pēc iespējas ātrāk pamanām uzbrukumus. Tāpat paralēli gatavojamies krīzes situācijām, izspēlējam dažādas mācības un izglītojam darbiniekus. Jo katrs liels incidents sākas ar sīkumu. Vai nu ar darbinieka kļūdu, vai neatjaunotām programmatūrām, vai kādiem citiem, it kā liekas sīkumiem, kas var novest pie lieliem incidentiem un negatīvām sekām. Bet uz pozitīvas nots visi kopā mēs noteikti varam turpināt darbu kā līdz šim, lai padarītu Latviju par visgrūtāko mērķi kiberuzbrucējiem un nodrošinātu mūsu pakalpojumu pieejamību nepārtraukti. Lielas paldies par uzmanību.
Paldies, Baiba. Ja drīkst, varbūt vienu follow-up jautājumu. Alberto arī savā prezentācijas noslēgumā minēja, ka izvarītos no šādām lielām arī pārslodzēm un citām problēmām, ka iespējams, ka mākslīgā intelekta sistēmas, algoritmi, gudrie algoritmi varētu nākt tālākā. Un šeit prezentācijā saskatīju teikumu, ja ir sasniedzams, tad kļūst arī par apdraudējumu. Kā rīkoties būvējot nākotnes sistēmas, lai cenšoties tās padarīt fleksiblākas, gudrākas, lai mēs netīšām neiestrādātu arī kādu caurumu, kādu drošības aizmugurējās durvis, pa kurām hakeriem ienākt. Jo viss jau beigās iet uz to, ka tehnoloģijas tomēr ienāk mūsu ikdienā arvien vairāk.
Protams, nenovēršami. Un šīs sacensība, kurš labāk izmantos mākslīgo intelektu uzbrucējs vai tas, kuram jāaizsargā infrastruktūra, notiek. Tā jau ir mūsu šens stāsts cīņas starp labo un ļauno, un skaidrs, ka ļoti lielas iestrādes ir gan vienā pusē, gan otrā pusē. Mēs savā darbā, diemžēl, vairāk pat saskaramies un redzam to, kā uzbrucēji izmanto AI iespējas un tās liek lietā, bet ir ļoti daudz kompānijas, kas pašlaik investē ļoti daudz, lai mēs varētu paļauties uz programmatūru, lai tā būtu drošāka, pārbaudītāka, tāpat arī ievainojamību atklāšana, lai tiktu laicīgi, lai notiktu jau labajā pusē, nevis sliktajā pusē. Tā kā es domāju, ka šī cīņa turpināsies un mūsu loma ir mēģināt izmantot visu to, ko mēs varam savā labā.
Ja nu kas, cert.lv.
Tieši
Tā ir tā e-pasta adrese, kur jūs varat uzrakstīt, ja nu ir kādi jautājumi vai problēmas. Baiba, liels paldies par dalību ACDC Tech.
Yes.
Let me switch to English for this next topic. We heard about storms, cyber attacks, but if there aren't enough problems on the table, let me put one more on there. And it could be called a silent killer. I'm not talking about sugar that we consume every day. I'm talking about underinvestment. We've heard that systems, they age. During this aging process, they tend to weaken, and when a storm arrives, I think it's like highlighting all the things that have not been done perfectly so far. And it is a topic of investing your financial resources as well in order to keep things up. And our next speaker knows a thing or two about that because he leads Estonia's largest electricity distribution company, Delfi.lv, serving almost or even more than 500,000 customers all over Estonia. And he needs to balance these investments together with, for example, also payments for customers, which can be too high for them to be able to afford it. It's a very difficult game, like Monopoly, but maybe even more difficult. Let's welcome on the stage the CEO of Delfi, Michael Harm. Welcome, Michael. Happy to see you here.
Thank you. Good morning, or actually it's already past 12, so good day to everybody. Thank you for the organizers for having me here. Thanks, Sandis, and it's really pleasure to see all of the colleagues, both from here, Latvia, and also from Ireland and other places. So yeah, my name is Michael. I will be shortly speaking about the resilience and how do we get there. And I put here a picture resembling the period that we are in. For those who have worked in the distribution system companies, at least in this part of the world, then spring is the best time to do this work because winter storms are behind you, thunderstorms are not here yet, so this is smooth sailing. But unfortunately, it does not stay for that or like that for long. And the horizon does look bleak and not so fun, not only because we know that the thunderstorms are coming. It is not only because, as we heard from the Irish example, the world we live in climatically is getting worse. What used to be a normal storm in the autumn months now is something that you do not want to bear. We do see it from evidence. But this is also because of the new situation we are in. We heard the cyber attacks are here, but we also heard that the other hybrid initiatives are here. And we are updating together with the Estonian government right now our resilience plan. And well, like 5 years ago, the status quo was something totally different. Now when we do our long-term plans, we are not talking about having a friendly neighbor behind the eastern border. This word is gone. And on the picture you see our dispatch center. These guys constantly need to be aware that the hybrid threat is there, and we need to invest to make their jobs easier. And what we heard from the Iberian example, this is also something that we here in the Baltics need to take into account. We have the storms, we have the cyber threats, and then we have the customers who are coming to us saying that the grid needs to be secure, it needs to be cheap, and there needs to be enough capacity so that I can connect these huge battery parks tomorrow. Because right now is the moment that you can monetize these battery parks. When you give me the connection in 3 years, then this opportunity is gone. And if we say that there isn't any capacity left, then we are the bad guys. And I definitely don't want to be the bad guy. So we need to come up with some kinds of solutions. I'm happy to say that if we look at the reliability part, and here on the screen you can see the SAIDI figure. This is the primary figure that we DSOs show to each other to compare if the quality is good or not. And these are only the fault-related SAIDI minutes in the Estonian grid, in Elektrolevi's grid. You can see that 2023 was really, really bad. This is something that should not happen. And this was because we had a really bad year climate-wise. 2024 was a year that was really forgiving, was really nice to be in, but in 25 the old times had come back. But as you can see, the impact is not as it was a couple of years before. And now this is the place I can say thanks to the Latvian colleagues, because the biggest win in getting the fault number down and in getting the SAIDI figures better is because we put focus on the line corridors. And this is something that we learned from here. The lighter blue is the regular maintenance. We decided to shorten the intervals and to catch up on some of the undone work from the previous years. But the darker blue is actually something we did first time in the history. This is widening the corridors, making the corridors as wide as possible. And we do see that this is having a good impact on the quality. Then, of course, we looked around what else could be done, and we formed our voluntary crisis reserve. We asked the people in the company, we have approximately 900 people working in the company. We asked everybody, would you want to get a crisis role? Would you be willing to come and help us if there is a need? About 600 people out of this 900 said that sure, give me an opportunity. Unfortunately, we only were able to give 200 people this role. The other 400 are still waiting what they could do. But this 200, and most of them are actually field people on the field, repairing faults, locating faults. So this has been a huge help. And now getting to the main topic. This is the investment part. You may have your corridors widened, you may have people, you may have even the IT systems up and running, but in the end, if the grid itself is above its lifetime, if the poles are rotten, if the wires are breaking down, then there simply isn't anything that you can do. In our case, right now, 27% of the assets that are there out in the field are above their designed lifetime. I'm not saying it's good, I'm not saying it's bad. I'm saying that we have managed to keep this grid up and running, although there is 27% of the stuff that was not designed to operate for that long. This is because of we have maintained it properly, we have repaired when necessary, but I'm also saying that there is a critical point that you cannot go over. I'm not sure whether it's 35, 45, but the point is there, and if you cross over it, then you just have too much faults on your hand, and you do not want to get there. And here is our plan for the future. So you can see these are the annual investments that we are making into the grid. They have gone up and down in the past years, but the plan is clear that in the next 5 years we need to constantly increase the amount of money that is going into the grid. And it has to be gradual, because when we say that tomorrow it used to be 150 million, next year it will be 250 million, then prices will just go up and we will just get the same amount of new network, and this is something we do not want. But we are on that path. It is not a guarantee, because it needs the regulator to actually sign this, the customers need to be okay with it. So this is a discussion that is ongoing, but we are on that track. And here is an example to show that the plan that we have is actually working. This is a snapshot of one of the islands in Estonia, the island of Saaremaa. Maybe some of you have been there. And here are the monthly faults on that island. And why I show that one is because this was the first pilot where we widened the corridors and where we had a targeted investment into undergrounding and also weatherproofing the grid. And the red line is actually the maximum fault number per month in 2025, and you can see that it is really low compared to the previous years. So we ourselves believe that this is a step in the right direction. The focus areas for the investments in the coming years are the weather resilient network. You need to have that one in place. You cannot get anything done without that. And then, of course, it is the equipment to clear the faults, and it is also the generators. We know from the Ukrainian example that generators are really needed if the worst happens. And we need to prepare for the worst, if we want or not, but we need to do that. And so the challenge now is that we need to get these generators, but if they are just sitting in a warehouse somewhere, then it will be a huge cost and not a wise way to do it. So we are coming up with ways how we can incorporate the generators into the planned maintenance, into the investment works, and also find other ways how to make this investment more useful. And I will skip some of the parts and maybe highlight the last one. It is the workforce. We need to invest into the workforce. We need to get more new people into this business because otherwise you may have the equipment, you may have the network, but you won't have anyone to actually use that one. So what is next? And this actually is the most important slide in this slide deck because all of us, we need to share this message and get this across that we have used this nice opportunity that in the past sometime there were huge investments into the grid. There was electrification going on. If you take this part of the world, there was the Soviet Union throwing a lot of money into the infrastructure here. And we have used this infrastructure, but this is getting to the end of its life. And now we need to replace it. And we also need to bear in mind that we cannot just have the same kind of network anymore. We need more redundancy. We need more undergrounding because the weather is changing. I am really, really sure of that. And we also need to invest more into the security side of the grid. It is the specialized fences around the substations. It is sometimes some kind of nets over the critical infrastructure. It is making sure that your control and dispatch center is in a safe enough location. These investments need to happen, and now is the time to do that. If we come back to the idea 5 years on that it would have been a really good idea to do it now, then you do not want to be in that situation. And then this brings us to the question of the funds. The funds cannot come from anywhere else, in my mind, than from the users of this service. We might have some kind of state budget allowance for that one, because this is not only for the end users of the electricity, it is also for the wider good of the society as a whole. So there might be this discussion, but at least in Estonia, in my position, you cannot hope that there is some magical European money that will come and help solve this issue. There isn't, at least in Estonia, in sitting my chair. So I need to talk to the regulator, I need to talk to the owner, and I need to have this discussion with the wider public, the end users of this service, because in the end this will make the electricity bill go up. And there is this also, once again, some line that you cannot cross because if the bill gets too high, then you won't get any new business in the country. You will have a lot of angry people in the streets. You are having the elections coming up. In Estonia, the general election will be next year. So this is also something you need to bear in mind. But in the end, there has to be this funding because these are investments that are really needed. And so when we come to the DSOs, then it is our job to show that we are not just going around asking for money. We are doing our part. We are turning all the stones over to see where there is hidden efficiency and where there are ways how to either postpone the investments or find ways how to actually then find the alternative. So this is also something that needs to be done. The flexibility is the easiest thing that comes to mind, but sometimes there are local alternatives. Sometimes there are negotiations with the end customers. So agreeing with some really remote customers that maybe it's okay for you to get a lesser quality in the service as long as you also get a reduced bill for that one. So because it doesn't make any sense for the other customers to pay for these huge investments to strengthen that part of the grid. So this also needs to happen. And in the end, the most important part is that resilience is something that the societies need, at least when it comes to energy. Electricity is the key driver of our everyday life. We just cannot live without it. So please help me in this regard and go around sharing the message that we need to put even more attention to this topic. Thank you. Thank you for having me.
Thank you, Michael. Yes, that's a tough job to try to explain these things to people because rarely they understand, right? It's like, my wallet, why are you climbing into my wallet? So maybe in the coffee break that will follow our next presentation and the discussion, we can group work this stuff and come up with better explanations as well. Thank you for right now. I'll see you in a bit. Round of applause to Michael. Jā, dāmas un kungi, vēl viena prezentācija, viena īsa paneļa diskusija, un tad jau mums būs arī garāka kafijas pauze, un arī kā pasākuma otrā daļa, kad varēsim neformāli patīkloties. Taču turpinam ar nākamo stāstu. Esam dzirdējuši daudz dažādus viesus, gan no tuvām, gan tālām zemēm, taču jāprunājas ar vienu no mūsējiem. Ja mēs varētu šobrīd uzlikt kādu dziesmu, tad tas būtu Aerosmith Living on the Edge, kā viņš raksturoja šo fórumu, bet, protams, copyrights un YouTube un vispārējais, tāpēc mēs neliksim šoreiz. Taču šī dziesma labi ir raksturo laiks, kuros mēs dzīvojam. Dzirdējām par kiberuzbrukumiem, par ģeopolitiskiem jautājumiem un visu citu, bet visam tam pa vidu tīkls turpina strādāt un laiks uzzināt, ko tad mēs šeit Latvijā daram, lai sagatavotos arī tai nākotnes realitātei. Dāmas un kungi, ar jūsu aplausiem Sadales tīkla valdes priekšsēdētājs un izpildu direktors Sandis Jansons. Sagaidām! Laipni lūdzam.
Nākamreiz varbūt mums vajag pašiem nodziedāt vienkārši, ja nedrīkst atskaņot. Ja?
Oi, ja es sākšu dziedāt tikai dušā, Sandi, tikai dušā.
Labi. Manuprāt, mēs, jūs esam jau gana nobaidīti no iepriekšējiem runātājiem, ka enerģētika tas vairs nav tāds easy peasy walk in a park, un tas nav stāsts par to, ka gaisma lampiņā vienmēr būs, un tas ir pilnīgi kā teikt, droši. Ja? Mēs zinām to, ka faktiski enerģētika un enerģija jau ir kļūsi par tādu kā kara instrumentu. Mēs redzam, kas notiek Ukrainā, mēs redzam šos visus izaicinājumus, plus vēl tam mainīgie laika apstākļi un tā tālāk, tā kā šīs atbildības nasta kļūst aizvien smagāk un grūtāk un atbildīgāk. Un mēs redzam, jā, ka notikumi pasaulē būtiski ietekmē enerģijas cenu. Sākotnēji, protams, kad sākās Krievijas iebrukums Ukrainā, visas enerģijas cenas, kā teikt, sasvārstījās un pat tik, cik arī mūsu reģionā mēs diezgan daudz vēl ražojam no fosīlo arī elektrību. Arī elektrības cenas leca līdzi. Mēs redzējām, kā degvielas cenas ar Irānas krīzi, teiksim tā, ir nosvārstījušās, un mēs redzam, ka ļoti vienkārši šīs fluktuācijas var būt vairākas reizes, pat nevis daži procenti. Ja? Tā kā tas izaicinājums būt šajā mainīgajā cenu pasaulē ir aizvien lielāks un lielāks, bet skaidrs ir viens, ka ja mēs spējam un varam saražot pašu savu elektroenerģiju vai enerģiju no mūsu resursiem, kas tepat, kā teikt, mētājās vai pūš vai spīd apkārt, šīs fluktuācijas būs mazākas, mēs būsim drošāki, un ja mums būs drošs tīkls un droša sistēma, mēs varam drošāk skatīties arī uz priekšu šajos izaicinošos laikos. Mūsu labais stāsts ir tāds, ka pretstatā arī, vai ņemot vērā arī to, ka vēsturiski jau mums ir Hesu kaskādes, un mēs jau kā valsts esam gana, teiksim, zaļa elektroenerģijas ražošanas ziņā vēsturiski, bet pēdējo gadu laikā mēs zinām mūsu, kā teikt, slaveno hokeja nūjas grafiku saules ģenerācijas stāstā. Uz doto brīdi pie Sadales operatora vien ir pievienojušies vairāk kā gigavats saules ražotāji. Pie kolēģiem arī slēdzās klātīm, arī droši vien, ka būs jau kaut kādu pusgigavatu, tā kā Latvijā jau 1,5 gigavati saules enerģijas ir. Vairāk nekā mums droši vien, ka šajā vasarā būs saulainās dienās nepieciešams, tāpēc labā ziņa ir tāda, ka paralēli saules parkiem pie mums slēdzās klātīm arī baterijas. Jau 230, 240 megavati saules parki ir pieslēguši baterijas, lai tādējādi arī savu vairāk saražoto elektroenerģiju varētu uzglabāt. Un mēs redzam arī to, ka tā saucamie stand-alone biznesi nāk iekšā, un mēs jau uz doto brīdi esam pieslēguši ap 30 megavatiem atsevišķi stāvošu bateriju parkus, un interesi ir milzīga. Izdevuši mēs esam vairāk kā 500 tehniskos noteikumus par 500 megavatu jaudu, tā kā arī šī bateriju uzkrāšanas stāsts nāk aizvien ātrāk un ātrāk iekšā pie mums Sadales tīklos. Bet vai ar to ir pietiekami? Droši vien, ka nē, jo ekspektācijas un dažādi, kā teikt, pētījumi un futuriskie redzējumi saka, ka elektrība kļūs aizvien pieprasītāka un pieprasītāka. Euroelektrika saka, ka līdz 2050. Gadam no patreizējiem 20% elektrības visā enerģijas tirgu elektrība izaugs līdz 60%. Mūsu klimata un enerģētikas ministrija arī lēš, ka uz 2050. Gadu elektroenerģijas patēriņš vairāk kā divkāršosies. Tad mums jāiet līdzi, mums jābūt gataviem, lai šo spētu nodrošināt un tam visam ļaut notikt. Un ko tad Sadales tīkls dara, lai mēs šos pārmaiņas, šo kā teikt, kustību nodrošinātu? Pirmais, kas mums ir jānodrošina, tas, lai klienti, lai patērētāji būtu droši, ka šī elektroenerģija būs, lai mēs varam savus paradumus mainīt, uzticēties elektroenerģijas avotam. Ja, mēs ļoti labi zinām, teiksim, arī tā pašas apkures sistēmas, transports, ja mēs neesam pārliecināti, ka mēs nokļūsim ar elektromobīlu no punkta A līdz punktam B, droši vien, ka mēs viņu neizvēlēsimies, tāpēc arī tas pats par elektroenerģijas sistēmu. Katru gadu mēs investējam savos tīklos, lai viņš būtu drošāks. Turpmāk tālākos slēdos parādīšu arī mūsu sasniegumus tajā jomā. Katru gadu pārbūvējam vairāk kā 1500 km mūsu līnijas, un mūsu tā ambīcija ir tāda, ka saviem gan investīcijām, gan viedajiem risinājumiem uz 2050. Gadu jūs neviens nejutīsiet to, ka mēs savā tīklā kaut ko daram, kaut ko attīstam, kaut ko būvējam. Visiem darbiem vajadzētu notikt tā, ka klients to nemaz nejūt, vai nu ir ģenerators pieslēgts, vai nu ir sprieguma aktīvais darbs, vai nu tīkls ir sakārtots jau tādā līmenī, ka faktiski to jau, kā teikt, viņš jau tāds ļoti vietas gudrs un pats sevi, kā teikt, uzturošs. Protams, blakus tam arī ir jaudu pieejamība. Uz doto brīdi mums ir plāns līdz 30. gadam izbūvēt vairāk kā 200 megavatu papildus jaudas, lai šie jaunie patērētāji, lietotāji un arī ģenerētāji varētu pie mūsu tīkliem slēgties klātīm. Uz šo gadu mēs pieslēgsim jau vairāk kā 100 megavatu, un tad atlikušajiem 4 vēl vajadzētu tikpat pieslēgt. Jā, šie 200 megavati daudz nemaz, bet tas ir tāda Jāņu rīta puse no mūsu nepieciešamās patreizējās jaudas, vai 50 000 mājsaimniecības, vai 100 lielāku uzņēmumi, tā kā šīs jaudas jau ir diezgan ievērojams tā, lai tiešām ekonomika varētu attīstīties, iet uz priekšu, un elektroenerģija nebūtu tas iemesls, kāpēc kaut kas nevar notikt mūsu valstī. Bet blakus tam, protams, mums jāskatās arī, kā mēs pārvaldam savu tīklu, kādas ir mūsu iespējas gan skatīties uz priekšu, saprast, kur būs bojājumi, kur ir mūsu tīklā vājās vietas, kā viņa novērst. Mēs ļoti būtisku arī soli esam spēruši pagājušajā gadā, kad faktiski jau pamata mūsu tīklu inspekciju un defektāciju tā saucamo mēs veicam ar droniem. Un arī šodien prezentētais viedā ģenerācijas pārvaldība, kur mēs patentēsim Eiropas līmenī, faktiski unikāls rīks Sadales operatoru līmenī, kā noturēt ģenerāciju pēc iespējas vairāk mūsu tīklā un ļaut ģenerētājiem ražot. Tā kā daudz dažādas lietas, ko mēs darām, un tas viss rezultējās patīkamos grafikos. Tendence ir uz leju, bet tas ir labi. Tātad bojājums skaits, ja mēs paskatāmies gadus atpakaļ, 10-15 gadus atpakaļ, faktiski samazinājies vairāk kā 4 reizes, no 40 000 uz 11 000, vairāk kā 3 reizes. Un otrs cipars, ar ko mēs arī ļoti lepojamies, tas ir šis saidī, cik vidēji viens klients ir bez elektroenerģijas gadā. Un pagājušo gadu esam sasnieguši ar 133 minūtēm. Mērķis uz 30. gadu ir 100 minūtes, tikt zem 100 minūtēm. Ar šo skaitli esam kādus gadus 3 uz vienu no labākajiem Baltijas valstīs, tā kā varam būt tiešām lepni, ka šīs iepriekšējās investīcijas un aktivitātes tiešām atmaksājās. Bet, kā jau teicu, labs bojājums ir tāds, kurš nav noticis, to mēs varam panākt ar investīcijām un tā tālāk, bet ja tomēr viņš notiek, un līdzīgi kā pieņemsim īrijas gadījumā atnāk vētra, tad mums ir ļoti būtiski, kā mēs to visu varam atrisināt, nodrošināt un ātri atrisināt pēc iespējas. Tāpēc digitālā tīkla vadība ir ļoti būtiska lieta, ko mēs ejam un daram aizvien vairāk. Pēdējos gados esam uzlikuši vairāk nekā 500 attālināti vadāmus tīkla slēģus, lai varētu attālināt tīklu pēc iespējas ātrāk lokalizēt, un radušos bojājumus uztaisīt tādus, lai pēc iespējas mazāk klienti šo bojājumu justu. Un tad, kad bojājums ir lokalizēts, tad mums ir vajadzīgs gudrs, strādāt gribošs, varošs un ekipēts darbinieks, lai šo bojājumu novērstu. Tāpēc investīcijas tehnikā, ekipējumā redzējāt pie durvīm mūsu tehniku, ko lepojamies, jo tikai tā mēs varam būt droši, ka mēs būsim spējīgi novērst vētru seku radītos bojājumus. Bet lieta, ko mēs skatāmies uz nākotni, tas ir, protams, tālāka kabelizācija. Plānos mums ir uz katru apdzīvotu vietu, kur vairāk kā 500 klienti dzīvo, aizvest vienu drošu kabelizētu līniju, lai gadījumos, pieņemsim, kā īrijā, nāk liels vējš pāri, lai mēs varam būt droši, ka šīs apdzīvotās vietas un šie klienti tiešām ir gatavi, kā teikt, jebkurai vētrai, jebkurai katastrofai. Protams, ka tas viss maksā, mēs tēmējam uz lielām naudām, bet mēs tā kā ceram tomēr, ka Eiropas Savienība arī mums var palīdzēt un piešpricēt, un mūsu ambīcija ir uz nākošo plānošanas fondu ap 400 miljoniem eiro, lai varētu investēt mūsu tīklā, investēt viedos risinājumos un kabelizācijas projektā. Tāpēc lūdzu, ja jums arī ir iespēja kaut kur piebalsot kādā kvorumā vai formā par to, vai enerģijas operatoriem ir vajadzīgas Eiropas naudas, tad lūdzu, kā teikt, ceļiet roku un sakat, ka tas viss ir mūsu nākotnē. Un, protams, arī izskanējušie kā teikt, draudi, fiziskie, kā teikt, un noturības draudi šajos mainīgajos apstākļos arī paģēra to, ka 72 stundu soma tas nav tikai kara gadījumā, tas arī energokrīzes gadījumā. Energokrīzes riski droši vien ir viena no vislielākiem, tāpēc mēs aicinām katru pašu padomāt par to, ka mums ir rīcības plāns energokrīzes gadījumā, mums ir kaut kādas powerbankas vai baterijas, mums ir iespējams arī kaut kāds alternatīvais siltuma ražotājs. Un tas, ko mēs redzam arī, ka šī izkliedētā ģenerācija, šie mājasaimniecības saules paneļi kopā ar baterijām, arī tas ir ļoti, ļoti labs un drošs, kā teikt, ierocis cīņā pret energokrīzēm. Sadales tīkls pats mēs ļoti arī aktīvi iesaistamies tieši fiziskās drošības aktivitātēs. Redzat kadrus no Izvaltas, kur mēs kopā ar augstsprieguma tīkla kolēģiem, LMT un Nacionālajiem bruņotajiem spēkiem zemesardzi veicām testu salas režīmam, atslēdzāmies no tīkla, nodrošinājām salas režīmu, tā kā šādām aktivitātēm un, kā saka, mācībām mēs tiešām varam būt droši, kad arī tu, ja nedod Dievs situāciju, mēs esam gatavi, mēs esam pratoši un zinoši. Tā kā, jā, cerams, ka mēs iepriekšēji runātāji un es neesmu nobaidījis jūs pavisam, ka no enerģētika tas ir kaut kas ļoti bīstams vai ļoti ievainojams. Nē, nav. Mēs esam droši, mēs zinām, ko mēs darām, bet, jā, kā Kažociņa kungs teica, jācer uz labāko, jāgatavojas trakākajam un vienmēr jāskatās tā pragmatiski uz priekšu. Un es esmu pārliecināts, jā, ka kopā mums sanāks, izdosies, un Latvija būs vieta, kur elektroenerģija būs visdrošākā. Paldies par uzmanību, tiekamies vēlāk panelī.
Jā, paldies, Sandi. Es domāju, ka var jau droši ieņemt arī vietu šeit pie mums uz skatuves, jo ir laiks paneļa diskusijai. Aprunāsimies un sapratīsim, ko arī autori ir sapratusi, kur varbūt nepieciešami vēl kādi skaidrojumi un uzsvar. Let me switch to English for this next panel discussion, as Sandis Jansons, head of Sadales tīkls, is one of the participants in this panel discussion, but we would like to see on the stage also the head of the TSO of Latvia, the CEO of Augstsprieguma tīkls, Rolands Irklis. Welcome. And welcoming back on the stage, CEO of Elektrotīkls, Mihails Harm. Welcome, Mihails. ESB Network Storm Review Manager, Karen McJoe. Welcome back, Karen. And of course, the CEO and co-founder of PlexiGrid, Alberto Mendes Rebelo. Welcome, Alberto. A panel of experts, and then there's me, who's not an expert, maybe an enthusiast. So forgive me if I maybe mix up some of the terms. I believe you will help me with that. But just to open up, we have prepared a couple of questions, and I will give our audience the microphone as well at some point for some audience questions so that you are involved as well. But we've heard a lot of talks, of presentations, a lot of things that were very alarming for our minds. And I just want to go through and maybe give you an opportunity to reflect, maybe to highlight something, maybe something you haven't said in your, maybe you didn't have enough time to say in your presentation. And let's start with Roland, because you weren't on the stage with the presentation. So maybe the opening words and reflections from your side, what seemed important, what maybe has not yet been said, and maybe if there's nothing to say on this matter, then with the opening question of what are the biggest resilience risks nowadays that we see. A lot of them were highlighted, but maybe something else. Roland, let's start with you.
Thank you, and thank you, Sandis, for organizing this great event. I think it's really mind-blowing, actually, to see all the development what we have now in electricity networks, and also the risks which are coming with that. So all this new development also comes with a lot of risks, and it was nice to see all this picture because we recently approved our new strategy for next 5 years, and actually all these risks which are talking today are attributed in that strategy as well, in one or other sense, and therefore I think we are on the right way. So there is no risks which we skipped or we are not paying attention on. But at the same time, there is a lot of work to do to mitigate all those risks, starting from physical security, which Sandis showed in his presentation here, system security with all new situation what we have on distribution level, also on transmission level. So there is a lot of more consumers coming on, more active consumers, and managing the system, operating the system becomes more and more complex. And also the weather, the climate risks as well, they are coming, and there is already some initiatives in Latvia how we can improve this resilience against the climate change as well. So I think it's good to hear that at least I felt that we are paying attention on those risks. The question is how fast we will be able to adapt to this new situation and mitigate all those risks.
Mm-hmm. What's the one thing that keeps you up at night of all of those risks? Because we put a lot of things on the table, everything from investments to weather. Is there a thing that is number one on your mind right now?
So if I know that the storm will be at night and that you can predict, so that can keep me awake. The difficulty is there is other type of risks. For example, cyber incidents can happen during the night, and then you have to wake up, and this actually happened, that we are solving cybersecurity incidents also over the night. Mm-hmm. So it's reality for system operators that this is work where you sometimes spend 24/7.
Mm-hmm. Thank you for highlighting that, because sometimes that's what we're not thinking about with everything that is happening also here in Latvia with all the drone alerts and everything. So yeah, a lot of risks that are in our surroundings are very volatile. For me as an event host, this is the first event ever where I have written in my script a thing that I will say in case there's a drone flying over me. So don't worry, we are safe. We have premises here that will keep us safe in these extreme emergencies, but it is a sign of times. Alberto, you were the first of presenters here on the stage. Maybe your thoughts so far, and maybe something you didn't mention here on the stage.
Well, we are living in a more entropic, world with incredible volatility in all aspects. The technology volatility, geopolitical volatility, and many other things. And I think for electrical engineers, we have been taught that go slow, don't rock the boat. I mean, engineering excellence is the fight against variability. Think before we think and change the procedures for TSOs or DSOs. Think it through 1 year, 2 years, test. And I think this is the first time where going slow is the problem. That's what creates the risk. You know what I mean? We have been all schooled in engineering schools that don't rush these things for risk management. But I think this is exactly now the other way around. Not going fast enough to make our networks ready for what's coming. Not what is to come, it's materializing, it's happening. It's not maybe could happen, it's happening, all kind of things, And I think it's a lot of reflections on leadership. What kind of leadership we need now for this we need faster leadership. We need to collaborate with companies outside our traditional supplier base to bring all these, capabilities in resilience, in defense, in dual use. So I think we should make some reflections on leadership, on collaboration, on innovation, on speed. It's I think, a very different culture. At least I worked many years at Vattenfall, right? It's one of the largest operators, and that's not the culture we have built. We have built a culture of take it step by step, take the time, but now we don't have time. So yeah, that's.
Mm-hmm. And one of the ending thoughts in your presentations, in your talk, was let's look to the future, let's look towards technology and AI systems as well. That's one of the things that you mentioned in the end. Do you see that could speed up things? And is there an underlying risk that maybe we don't see in the future with this?
Well, we're going down the rabbit hole like Alice in Wonderland. So for Pablo and I, when we started this 5 years ago, you simply didn't know what we were about to find. So every week we learn new things about this, so we're still learning. But this is extremely important. We cannot do LLM thing. That's cowboy. We connect, they hallucinate. They are connected to fake news or to materials created by other LLMs. You know what I mean? If you train an engineering system like this, it will create bigger problems. So I think we need to discuss a lot about the governance of this AI. It needs to be physics rooted. It needs to be within. The problem of AI is that we let the genie out of the bottle. But in critical infrastructure, we need to keep the genie on the bottle. I think we need AI, but it needs to be governed, it needs to be confined. We cannot mix training data with infer data. That was a golden rule that Elon Musk said, shit, if we start to do this, we start to break some golden rule. Remember, he wanted to stop for a while, the whole thing, right? But nobody listened and we just went. I think in critical infrastructure, we need to keep the genie in the bottle, confined, under the control of the operators, with human on the loop, with all of these things. Otherwise, we are solving some problems, but we are creating new vulnerabilities, right? So I think for me, AI is not an option, because we will be attacked with AI, so you need to be prepared with AI on the other side. But it's got to be structured and governed very thoroughly, but also quick. We don't have 10 years to do this.
Karen, I want to forward this question to you, maybe to follow up on what was said in your situation when going through these storms. Was there a technology that you wish you had already had there, and maybe some points where technology even can help us?
Like, I think I'll bring it back to the situational awareness, and maybe I'll elaborate thinking about technology. But it's not just in times of storm anyway. It's not just the strength of the assets. It's understanding all of the vulnerabilities, whether it's vegetation, trees, forestry, areas of weakness. So I think in terms of technology, absolutely, we are beginning to and have lots of different pilots using LiDAR and satellite and understanding how we can use this data again to, during those times of storm and beforehand, really understand the vulnerabilities and build in the resilience from the data that we're finding. But to elaborate further, I think, on the risk, and you asked about the biggest risk, and situational awareness comes into it. If you think about it, during a storm, it's a really good opportunity for others to exploit that. And in terms of other vulnerabilities, maybe cybersecurity, during a storm, you could have other vulnerabilities exposed, and then you start to think about polycrisis, and I think we need to think about this broader, and investment from all the different angles is really important, so that we're not just looking at individual events, but we're actually looking broader and what can happen in times of vulnerability. But in terms of technology, absolutely, we are using, as I mentioned, drones, understanding how we can really, use that data then to build in resilience into the network.
Once these huge events happen, usually afterwards, the understanding that we need to upgrade something, fix something, it's very near and understandable. Was there a thing like right after what happened where you said, okay, we need to fix things, let's do this, and everyone was, okay, let's upgrade. Was there like an upgrade to the system which you got right after the storm, which everyone was all in on?
Like, thankfully, in ESP Networks, we've been investing a lot of money on the network for many years. And we mentioned there's over, €1 billion a year. And we've just started a new contract with our regulator that's been approved, which is multiple times that. So I think we've always been investing in the network, and the network, in effect, did stand up. The big thing for us was, and Michael mentioned it, engagement with stakeholders around vegetation and forestry. So that is the big area of focus at the moment, on how we best manage our network that runs through vegetation and forestry. And I think the risk of wind blow, the risk of soil type that affects the forestry is really important. So that's a big area for us at the moment.
Michael, do we really need a strong crisis to change minds and to gather investments? Because sometimes it seems so that only when everything goes to waste, then we need to come together. Let's make fast decisions, quick investments. Let's upgrade. From your perspective, isn't there a better way?
Unfortunately, there doesn't seem to be a better way. For some reason, it is always like that. If something is good enough, nothing gets done. In our case, back in 2022, when we had the regional crisis, 1 week or more outages, then this rang some bells, and we got some extra funding for getting things done. In that, this is the Saaremaa island example. Government said, take 20 million euros, go and underground things, do whatever needs to be done, because there is a problem. And it didn't matter that the same kind of problem was elsewhere as well. this was just like unfortunate event that they had this really bad weather. The grid is similar elsewhere as well. So yes, the short answer is there needs to be a crisis for people to wake up and understand that this is actually a problem, that they actually want to put their own money there as well. Because otherwise, if it's good enough, then let other people get and then deal with that.
Is that the biggest resilience risk that you see, or there's something else on your mind when it comes to the grid and us being resilient to these risks?
I guess the biggest risk still is, or the biggest unknown, I would say, is the situation we are in when it comes to the acts of sabotage, when it comes to things that you simply cannot control. And getting back to the beginning and answering a question, what keeps me up at night, this is the question, have I done enough? Have we as a company done enough to prevent what could have been prevented?
Sandis, let me challenge you. Has Sadales done enough? Because me, as a partial insider with preparing for this and seeing what you're doing daily, we're seeing technology displayed here. We're going to hear about concrete innovation examples as well. But how do you feel about these matters? Have we done enough here in Latvia?
It's never enough. There was kind of song like that. Well, can't get enough. Satisfaction.
That was a positive song.
But if seriously, then of course the current situation, you never know when you wake up in the morning what will gonna happen. How many drones flew somewhere? Something happened, didn't happen. Cybersecurity, then the weather. But I guess in our case, of course, you have to work in all directions. Investments, cybersecurity, your own self-security, but the one big issue and what we have heard from Ireland case is communication as well, because when when the action happens, or bad things happen, then the most critical issue is first to give out to society information that they know that we are in control, and then of course to understand ourselves what has happened and how we can deal with that. So preparedness for those different kind of crises, it's really crucial. And as well within the company, each employee should know what he or she should do in a particular case. The good answer or knowledge as well is to do nothing, but that should be told and the people know what they should do. So, and one more thing from the first your question, I think the friendship and love for DSOs is very important because we can share the information. We are not kind of really competitors, so we can share the information, show the cases, tell to the societies that, look guys, in Spain, there was such case. Everything was okay, but it happened. We should be prepared. In Ireland is not the most undeveloped country, So it's quite good and etc. But still, if the circumstances comes like that, there might be situations.
Is there love and friendship amongst all of you when it comes to communication exchanging?
And that's the end of my question. When I see Mikkel, I feel that we are like in a family, some kind of, because we in the Baltics really have a good cooperation and a friendship, and that's what keeps me more kind of better sleep at the night. I know that if we have problems, we talk to each other, we know the best practices and etc.
Is there room for improvement when it comes to cooperation between countries, which you see?
Cooperation these days is not optional, it's necessity, and we have the cooperation among Baltic countries, especially on TSO level, it's very important because we interconnect the countries as well. So, and there is communication possibility directly on operational level between dispatchers in the control rooms and also on management level. So if there is a real crisis situation, I can pick up a phone and call my counterparts in Estonia or Lithuania anytime.
Yeah, I might just interject. as a thank you a year on for the support that we received back in Storm-Aon, we organised just in March a conference which some people in the room attended for utilities. So really a conference around storm resilience. And I think, look, the energy in the room that day and as leaving, I think we definitely built up lots of friendships and relationships that we will now carry on. So even today, coming in and seeing friendly faces was really heartwarming. So yeah, I think definitely. And then to add the at EDSO level, that mutual aid agreement that I mentioned earlier is really the first step. Establishing that is really the first step of strengthening, the relationships through a structured way, so that in times of crisis in both, we can pick up the phone and we've already got some preparedness ready and we're familiar with each other, so it makes it all easier. Yeah.
All right. I don't see anyone reaching for another word for this matter. I want to turn to our audience maybe right now just to check if there are any questions. Please do raise your hand. We have a microphone. Yes, we do have a question over there. Any more questions so that we see right now? Okay. Hello, what is your name? Who do you represent and what's your question?
Yes, my name is Nabil Belbashir. I am from North Research in Norway. And I want to ask a question to bring kind of light into the future, because we heard a lot of bad things today and dramatic situation. Of course, we are in a very difficult situation. But if we speak about innovation, to guarantee the energy security, there is also the line of geothermal. And just in the last 6 months, American companies discovered technologies that you can go 20 kilometers down, and then everyone in the world can have 24/7 energy without wind, without weather, without climate. Just drill down 20 kilometers and build technology that can harvest that energy. So is there anything of you who is also working on this topic, geothermal, for the future, for the energy security and resilience?
Thank you very much for your question.
I have geothermal heating in my house in Stockholm, but it's only 20 meters down, not 20 kilometers.
20 kilometers, okay.
We're digging just 70 centimeters. That's to dig the cable.
Okay, okay.
Not yet.
Not yet. Is there any talks, or is it a matter of huge investments that we don't have, matter of priorities?
But I think this brings up the issue that the times are changing. And sometimes they are changing very fast. And it just takes some kind of small things to turn around thinking, to turn around ways of living and the habits and etc. And it's like the electrification. We're talking about electrification in EDSOs and Energoapgādes for some 10 years. And it's like we are praying and talking, but it's coming very, very, very slow. But it might be the situation like you saw with our solar panels and etc. when it just explodes. And then we have to be ready with the grids and with the systems to take it in and to take it in a smart way that we are not collapsing all the system and etc. So the times and this changing of the behavior and gadgets and things, it's very, very, very...
I guess it's a matter of also priorities right now on which we concentrate, especially in the Baltics. We're working with wind, with solar, and that is a challenge in itself to explain to people why there's a park opening up right next to them and how that benefits and strengthens us. Maybe geothermal is a technology in the future to definitely look into, but for us in the Baltics it might be hard to comprehend right now.
If I may, just really quickly, geothermal in a sense of heat pumps, definitely already here, in a sense of let's make electricity out of it. Some pilot projects happening also in Estonia. But I guess the best part about your question was this focus to innovation. And when I listened to your presentation, this islanding inside of the distribution systems, this is something that is now coming onto the table as a solution for a problem that we didn't know we have before. So keeping small systems alive inside a huge system that maybe someday is just offline or trying to get the 330 kV lines back up again. So innovation definitely as a topic is on the table.
Yeah. Well, let me really look at the audience. Maybe some more questions right now. Yes, there's a question right there. Hello?
Yeah, okay, I have to respond to my colleague. I'm Atle Ollerud, also from North Research. So I'm an enthusiast. I have 2 EVs, part of the flexibility market. I have 200 meters down of geothermal energy. But maybe this goes to Alberto regarding the flexibility market. So when you transition to a distributed power system, you rely on these backups for islanding. And when I'm at work, my EVs are not connected. So these are not part of the flexibility market. So you need batteries or some other type of power. But the battery industry in Europe is not succeeding because of China. So if this is a critical infrastructure, should we rely on China? So what are your perspectives on this distributed energy?
Thank you.
Yeah. Well, there is now, we passed 10 gigawatts of demand response now active. Any customer here from Tiber? Any Swede? Well, I have my heat pump and my EV with Tiber. That's the Flex Taylor, it's Norwegian and Swedish. I think they're already doing 3 gigawatts of frequency response with EVs. TSO market, really advanced. And that's nearly as much as the Swedish hydro fleet for regulation. So it's not Mickey Mouse numbers anymore. It's becoming big. And today we talk grids, but we need to think downstream. We need to talk retail as well. So I think the future of this is Flex Taylor. The incredible thing, and I have your app, anybody on the coffee break I can show you so that you can see, but it's so easy because you need to make it easy for the consumer. So to put your car on Flex, you just take I couldn't believe the first time I did it with my electric car. So you take a picture of the number plate, it comes your car with the color of your car, with the rims of your car, because they have developed this back-to-back with all the manufacturers. Any brand, they have all the brands of electric cars. And then if you don't need a smart charger because every car now comes with charge control and connectivity in the car. So if you don't read the contract, do you read the software contract when you install a printer? Probably not, right? So you say, yes, yes, accept, accept. In 45 seconds, it's online. And the same thing with the heat pump. I had an old one that broke. To that one, you have to buy a box, and it takes 45 minutes or something to set it up. But with the new one, when the old one broke, it just comes with this. So it's like a printer. Yes, yes, accept, accept, 1 minute, done. And that's why you have now thousands of megawatts, because so one is, it needs to be extremely simple, and you don't need to be electrical engineer to do it. It's just like an app, and it's so easy, and it works, and it saves money. People are doing it. I mean, Tiber has now 25% of the retail market in the Nordics that they took away from Fortum and from Vattenfall and so on. But in reality, they have 90% of the market that is flexible because they have this app and it saves money and it's very, I mean, retail margins are only 1 or 2%. So, but with this thing, I can save 30% on the energy part of the bill. So, you know, no normal retailer can compete. So this is unstoppable and it's becoming bigger and bigger. Now Tiber is going to continental Europe. Octopus in UK came from nothing to become the largest retailer. They also have the similar apps and the same things. So I think it's big. Now, of course, what we have to connect is the layers of intermediate stack between all these things on the edge, ultimately back to through the DSO, back to the TSO. And we're building those bridges slowly. I see this very much as the fintech. You remember the fintech? Mm-hmm. I think about this like an onion. So the core of the onion is the core systems of the banks, which are programmed in COBOL. That's code from the 60s, if you know COBOL, right? And then you have different layers, and then you have the end consumer on the end layer. And we love Revolut, but it all started with, how was it called? PayPal, right?
On the non-banking.
Yeah, but PayPal only has any value to the extent that it connects through the different layers of the stack back to the COBOL systems. Because in the end, if I want to send money, in PayPal it takes 5 seconds. If I log in the bank, it takes 10 minutes. So I love PayPal, but it's got to be connected through all the layers of the onion for this to happen. And this is exactly what we are starting to construct now on the electricity onion. You have these guys on the edge with all these new innovations, but we have not fully integrated through the value chain back through distribution back to transmission. I think this is the key. But if we do that, we're going to have the hell of a system, I can tell you. Robust, flexible, competitive. There is no contradiction between those things. If you apply intelligence, you can achieve it all at the same time.
Speaking of electrification, how do you balance? So resilience is important, but electrification is important. Our society relies more and more on electricity, for EVs and everything else. Where's the balance, Roland? Where do you find the priorities amongst that?
Electrification is something which happens constantly, but now the speed is even higher. So we started more than 100 years ago, and consumption of electricity was very small, and then increased. And historically, how we solved it, we built new substations, we built new power lines, so we built bigger. What we need today is we need not just to build bigger, of course we still will need some additional substation or additional power line, but we can build smarter. And that's very important. And there are several pilot projects which we are doing also on AST level. For example, there is so-called technology dynamic line rating. So you can, on real time, evaluate the capacity of your network, of your power line. Historically, it was one just on static, so static data. Now you can, in real time, monitor the situation and give more capacity on the same power line. So you can use the same power line as before, but transfer more electricity to that one. And also everything else what was said here. So on one side, additional consumption, additional generation at TSO or DSO level, so it creates some problems. And we heard about those risks and difficulties what we have. But as Alberto said, we can also have a solution there. One example, again, from TSO perspective, there is new solar parks and wind parks currently connecting to our network. Last year, we opened the balancing capacity market, so Baltic balancing capacity market after the synchronization with continental Europe. And one of the most active new participants which are coming on that market are exactly the solar and wind parks. So they can create balancing issues, but they can be also a solution for the problem, because they also can be flexible, and especially if they combine their technology with battery parks. So this flexibility can be very, very, very useful for grid stabilization and those solutions. So there is, by building smarter the system and making more smart solutions on technological and IT level, we can provide more and make our systems more effective and more resilient at the same time.
Everyone's nodding, everyone's agreeing, technology will help us, but Sandis, what are maybe some of the obstacles? Why is it not happening faster? Is it money in the end?
I think another aspect as well is that I guess today we all know already, and we can agree that the fossil fuel is expensive fuel. And it's fluctuating as well with crises and et cetera and et cetera. So the one, some kind of, Gulf is closing down and the prices are jumping up, and the renewables, they are not stable in terms of production, but they are stable in terms of prices. And if we want to have a cheap energy, no matter is it electricity or heat or whatever, then renewables, this is the future. And it's not like a way back, we can say that the green 55 and et cetera, all is bad and et cetera, but the trend itself, it goes to the renewables, and we just simply have to cope with that. And it's not way to choose, so we just have to live with that. Otherwise, we will pay for electricity 300-400 euros per megawatt every day, not just in a cold, bloody winter night. So it's just it's no option to choose. We just have to go.
Any more comments on this from our colleagues? We are nearing the end of our panel discussion, and I really love the slogan of today's forum: resilience is a verb. It's something that we do, something that we act upon. Maybe after today, is there a thing that you will do or your colleagues will do more in order to bring more resiliency either to your networks or to your organizations? And maybe one thing that you expect from others, and you can address this to anyone. Throw it out. Maybe it's the government, maybe it's the partners, maybe it's the companies, the businesses, whatever. One thing that you will do towards resiliency, and one thing that you expect from others to do, so that maybe by 2035, we can say we are resilient and things didn't go as dark as we sometimes paint it in these presentations. Who wants to go first? Open question. Everyone's smiling.
Well,
Let's start with you.
I can try.
Yes, thank you.
I can try that the one thing is communication, and the communication from our side to go out and to tell the truth. Otherwise, if we don't tell the truth, then somebody else is telling their truth, and the truth might be not the real truth. So we have to go out and tell what does it mean, resilience in energy, that we have to face we can face the bad times, and we just have to be prepared for that. So
how will you do that? In what ways?
No, well, with events like this, you know,
yeah.
And of course go to the politicians, go for the tariffs and etc. Go for investments, and we just have to go. This is our duty to go out and shout and tell and educate society that we have to do it. And from our side, we have to communicate each other as well, and that's a big thing. So we have to be best friends with TSO, we have to be best friends with our neighbors, and we have to listen to our colleagues from abroad. And I think the communication, it's a tool, because things are happening everywhere. And if we hear the samples from somewhere else, we can adapt it, we can learn it, and that's a big value.
Roland, maybe let's continue. Latvian.
Yes, this forum is a lot about technology. But I would say for resilience, we need also to invest a lot in people, in human. Because the resilience starts with each of us. So how ready we are, how prepared we are for different situations, for critical situations. And then also people who will be ready for these new situations will be also more ready to understand the risks, the topics, and also come with solutions to those risks and challenges. So I would say that by investing in technology, we shouldn't forget about the people, because the people is the very beginning and also the core solution for all those challenges we have.
That's what you will do on your side, more investment on people and training and workforce.
Exactly.
And what do you expect from maybe other players? What would you throw out as a wish for the future?
So we have very good cooperation with Sadales tīkls, but I believe that we will need it even on a higher scale in the future as well. So because historically the Sadales tīkls were more like passive part of our service, so we very predictable, very so not taking we didn't take much care about what's happened on your side. These days you are more active, more dynamic, and everything which comes from your side or to your side, it's another scale. So we will need more and more cooperation. And what is good with Sadales tīkls, we have this cooperation on different level, on data exchange, on system operations, and today also even on very basic security level, like the military trainings which we had 2 weeks ago on Latgale.
All right, Michael?
Yeah, thanks. First of all, totally I agree with all of what was said before, and I can give our example that we did a joint long-term development plan with our transmission system operator, and has been a really good exercise and a good result, so definitely something to do success to you as well. But coming to what I would ask from the policymakers, for example, to bring us more resilient society, it is the economic growth and more growth in electricity demand. We haven't seen electricity demand, can't remember when we had last time year-on-year electricity demand. Okay, maybe last year couple of %, but actually there should be. In Ireland there are these data centers that are bringing demand. We don't have basically any, so if we would get more electricity demand, we would get more attention to the electricity sector, we would also then automatically get more investments into this sector. So this would be my ask to the others. What I myself will do, it is going around talking about this difficult choice we have, but I will put extra focus on trying to find some smart solutions, how to reduce the demand for investment and keep the bill down, because the electricity bills are already really high.
Try to address this question to you as well. What do you see in terms of on a more global scale resilience?
Well, I think from us in Ireland, okay, we're here today to talk about a storm event, but really it's the unpredictability of the entire risk factor, and it's not just obviously storms, and really for us to attend things like this to really understand the landscape that's coming, because it's that how the system operates and will behave under all of those stress factors, to continuously understand that. I think what we'd ask, we've a lot of people to depend on in terms of resilience, but I think what I would ask other utilities is to share where things don't go wrong, don't go right. So sometimes the best learning is in the things that don't work. So I think the ask would be to share where things go right, but also where things and measures and interventions don't really go well.
Actually, amongst not just electricity providers, but other utility providers as well. That's a good idea. Okay. Alberto, you can close this circle.
Well, for me, it's we're gonna Grid 2.0 is like a hybrid system where you have traditional firm capacity that is essential because it's the backbone of everything else. But it's not capex or flexibility. It's like the yin and yang. That's what, a Taoist cannot understand the yin without the yang. So, and it's like mixing oil and water that normally we are not used to mix, right? So we can provide some help to understand this new complexity, especially for planners. How do you plan for this hybrid system? What is the optimal blend of flexibility and batteries and traditional capacity? And where to put these batteries, for example, you know what I mean? So we can help a little bit with that. But what I will ask is that think about the next generation of talent you need to bring on. Because if you know Myers-Briggs MBTI test, have you done it? I'm sure it's one of the oldest industrial psychology. The best operators are the SJs, and the best innovators are the NTs. And normally what happens is that what gives calm to one of the SJs give high blood pressure to the NTs and vice versa, right? So one of the few things I learned in my life is that what makes a great innovator makes a very bad operator, and what makes a great operator doesn't necessarily mean that you are great at innovating. And how are you gonna blend these two cultures? And you need to bring the generation set engineers, and if you want to bring NTs, you're gonna have to make your companies exciting. AI first, AI native. Otherwise, they will go to Tiber or to Tesla or to other companies. But now you need this kind of talent in the TSOs and the DSOs. So that's what I will ask for you and the regulator, who is not here on the table, but also if you want, the regulator, you want to digitalize the system, digitalize yourself and recruit young engineers who can understand the grid that you have to regulate. Otherwise, how can you regulate something you don't understand? So that will be my ask.
I do not envy you as professionals.
They have a mission impossible job.
Right? Seems so. But with the technology capacity, with more communication amongst others, with more investment into the systems for us to be future-proof, I think even these guys can have a good night's sleep, right? So a round of applause to our dear panel discussion members. Thank you very much. Thank you. All right, I'll quickly switch to Latvian to explain over the things to come. Tiešraidi esam šobrīd jau arī